figured out how to test it yet. When I do, then I'll probably try and set that up. But I looked at the thing that we talked about the other night that they were saying, that Foucault's pendulum. I looked into that a little bit, and from what I can see, it seems like it's fairly bogus, especially being at least partially, if not entirely, based on this some hypothetical or theoretical concepts.
It's actually
Okay,
not.
we're joined by Brenda. Brenda, can we just check your mic there?
Super is.
Yes. Hello.
Okay, you're a bit low. Say it again.
Hello.
Yes, that's better. Right. Okay. So Brenda, what do you think?
I don't think that waves have anything to do with the curvature of the Earth.
They don't. That's true. They don't have any effect on the curvature of the Earth. You are absolutely correct in that assumption.
And if my observer height is higher than the waves, then the waves will never obstruct anything in the distance.
And if your observer height is below the waves...
Sure.
Cool, thank you.
But waves are not usually 6 feet tall, are they?
The shoaling effect, along with the wind-driven waves, absolutely, on quite a lot of occasions, most definitely are. You need to understand what swell is, Brenda.
No, so I understand. So if I make an observation, say, not from the beach, but from an elevation above the beach, say 50 feet, I'm not going to see any effects by shoaling.
It's unlikely, yeah. But when you're down at the beach, anything under, let's say, 10 feet or so, or 15 feet, let's say 15 feet to be absolutely perfect. So anything under 15 feet, you must account for that. You must account for that. You must know your swell reports, the topography of the land that you're filming from. You must know the wind data, and you must get an accurate height above the shoreline to be able to get your calculations done properly. And once you've got all them and you put them in, even though you may be 15 feet above the water at your, at the shoreline, for your calculations, it's quite often that you may have to just put a 7-foot observer height in, because it's likely that there may be 8 foot of obstruction or higher waves than where you are at the shoreline out to sea. So you must deduct that.
So shoaling is something that only happens in the sea, the oceans, right?
Correct.
So if, for example, I'm taking images from, say, a lake or an inland body of water, I'm not going to see shoaling.
No. Unless it's a ginormous lake that has some kind of tidal effects, but it's highly unlikely.
There are no lakes that experience tides. Tides do not affect by lakes.
That experience a tidal effect. There are some big lakes that do have tides on, Brenda.
There are none. There are none that I'm aware of. None.
Well, you might be wrong there, Brenda. Right, okay, so yes, you don't have to account for it generally in lakes, but I am pretty sure that there are. Let me just Google that actually. Are there tides in lakes? There we go. Studies indicate that the Great Lakes spring tide, the largest tide caused by the combination. So yes, so the Great Lakes. So there you go. So the Great Lakes have them. So I was right.
Does Lake Pontchartrain experience tides?
Well, Lake Pontchartrain is actually connected to the ocean, so yes, it does.
But that's just a matter of a few inches or a foot or so, right?
It's still a tide, Brenda.
A few inches is still not zero.
Yeah, but But it is just a few inches or a foot or so.
That's true.
So
But
will you admit
asked me,
now
did it
that
have a
it
tide?
does? Yeah. You said they absolutely don't have, and he's shown you that, yeah, it does happen.
That's 'cause
So
it's
you could at least
connected-
say, okay, Randy, I was wrong.
I
But
already did. I said it's connected to the ocean, so yes, it does. Yeah, but it's only a few inches, right?
Yeah, I think it goes up to around about a foot. I think is the difference.
So in Lake Pontchartrain images, we can safely ignore tidal effects.
Pretty much, yeah. But
And,
why are we discussing
the Great
Lake
Salt-
Pontchartrain?
Or the Great Salt Lake. We could ignore tidal effects in the Great Salt Lake.
Well, I wouldn't say that because the great. Let me have a look. I'm sure the tidal effects are quite substantial on there. Let me just. Don't need that one. Let me just. The Great Lake. I'm pretty sure they are quite high. Oh, hang on. No, I might be wrong. Studies indicate that the Great Lakes spring tide, the largest tides caused by a combined forces of sun and moon, is less than 5 centimeters in height. So, although it does have a tide, it is very small.
Right. So then I think that we can safely say that Soundly's images taken across Lake Pontchartrain or Tim Osmond's pictures taken across the Great Salt Lakes do not need to take into account shoaling or waves.
Correct. And I never have claimed in any stream in all the time that I've been doing this that either Soundly or Tim Osmond has experienced any kind of shoaling effect whatsoever.
That's fantastic. So those images clearly show curvature, obstruction due to curvature.
They show a form of curvature, but not Earth curvature, Brenda. Have you not been following what Brandon Toy's been doing?
There are different types of curvature.
Have you not been? Have you been following what Brandon Toy has been doing?
I'm sorry. I apologize for the sirens if you're hearing those. Did you hear those? Sorry.
Yes, I did.
Yeah.
Yeah.
Sorry about that.
So-
I live.
no, that's all right.
I live
Okay,
downtown.
so
I live
so
downtown. So
let me ask my question again.
I hope somebody hasn't had an accident out the front of your house.
So over the
I
past
live-
couple of weeks, past 2 or 3 weeks, myself and Brandon and Toy have been working upon these fish tanks with different types of gradients inside of the fish tanks, and we've found coincidentally a method to give the same effect as what you see in Lake Pontchartrain. How cool is that?
Pontchartrain isn't refraction
Why would you say that?
because the images are of power lines.
And you don't think they are suffering from any forms of refraction at all?
There is some towards the very end of the images, but for most of it, no, it's not refraction.
So the furthest part of the image, i.e. the angular size of those pylons that are in the distance, which are far smaller than the ones in the foreground, those ones that are in the narrowest regions are getting affected by refraction, those ones that just happen to be able to appear to be curved.
You can see curvature along the entire length.
That's perspective, Brenda.
That's not how perspective works. Perspective would produce a straight line, not a curved line.
Not when you include the results that we've been working on as regards refraction, Brenda.
There's no refraction.
There's always refraction, Brenda.
No,
in a gradiated system that we live in, with the dense system,
yeah.
with the densest regions being at ground level, at sea level, we get these effects
In Soundly's images of the power lines, they curve.
that are at sea level.
They curve.
Very
It's a gently curving line, not a straight line, as predicted by flat Earth. it directly refutes flat Earth, and it's not due
I
to
think-
It's not due to refraction.
Brenda, what is refraction? Can you explain it?
Well, let me just answer to Brenda. I think I think that the work that Brandon's doing right now, and the work that I'll be doing this following week, because I'll be doing some similar tests, we should be able to come back with a comparable result to what sound has got. I would be very confident that we could recreate that in the fish tank.
Possibly. However, the pylons, the power line towers, are not in water; they're in the air.
Brenda, is Randy was doing this test? Is it sinking? Are you agree it's sinking? The light is bending down with density.
Yes, the light always migrates downwards. Whether or not it's a ray, I don't believe it's a ray. I believe that it's more just it's a different form of vision that we have. You know, I don't
Can
believe.
someone
I don't
pop a
believe
link
that
into
it's.
the chat?
I don't know what a different form of vision would be. I have
Well,
no
I believe. Well, let me finish. So I believe that what we observe with our eyes, we aren't looking at beams of light shining into our eyes. We are looking at a different form of vision. So saying that we can use a laser and stuff like that, a laser is good to demonstrate the principles inside the tank, but I don't think it has the same. It's not the same thing as looking at an image in the tank or something inside the tank, a physical thing that you can
So you
touch.
think? So what is this
So-
different? So what is?
So let me
this
finish. So let
different?
me finish.
I thought you were done. I
So the
thought you were done.
physical- Right. Okay. So the physical thing that you can touch and place inside the tank, the way we visualize that, how we see it, however it represents itself to us, whatever comes to us, or how our eyes perceive what we're seeing, ends up bending things down. Now, with lasers, yes, you can make lasers bend down and stuff like that, but they're more something that you cannot touch. You cannot touch that. You know, those lights you can't touch, you can't fit. They're not tangible. But the things that are tangible
What do you mean?
have a different vision to what a laser has. You know, so what I think that when we put a similar thing inside these fish tanks to perhaps recreate Soundly's pylons, we will see that same effect. I'm pretty sure of that.
What is this thing that you can't touch? That you think you can't touch?
Well, you can't touch a laser, Brenda.
Yes, you
The
can.
light from a well, you
Yes,
can
you
touch
can.
the physical laser. How can you?
Yeah. You can shine it
Can
on
you?
your hand.
The light.
It'll burn a hole in your hand.
So you can grab it and you can move it around. You can play with it.
You can bend it with.
It's not a physical thing that you can touch, Brenda.
Light is physical.
It's not a physical thing that you can touch.
Yes,
Brenda.
it is. Yes, it is. Light is physical. Shine it
The
on your
table. This table is a physical thing that I can touch. This keyboard is a physical thing I can pick up. The mouse is a physical thing I can click. But the laser light, I can't do anything with that.
Yes, you can. You can shine it on your skin, and it'll burn. If it's strong enough, it'll burn a hole in your hand.
Can I tap it so it makes a noise?
Yes or no, yes.
Can I tap it so it makes a noise, Brenda?
It will burn a hole in your hand. That's all you
Can-
need for it to be physical.
Can I tap
No,
it?
that's an effect of it. Doesn't
Can I
make
tap
the
it?
light
Yes,
physical.
that's the effect of it being physical. Energy is
There's another
physical.
example.
No.
Yes, it is. Yes,
So
it
can I
is.
tap it,
Energy.
Brenda? I don't want this to get into a semantic argument, Brenda.
Brenda is right. A little bit right there.
So I don't want this to get into a semantic argument. I just want to basically explain the two different ways that we see. Laser light, something you can touch, there's two different things.
They're
So
not. They're not. You're wrong.
I'm getting a bit of feedback from somebody. Is that from you,
Is
Crow?
it me? Oh, okay.
Possibly.
I'll mute.
How's that? Yeah, that's better.
Can I say
Yeah, that
the
was
laser
it.
can make a physical effect, but no. So Brenda is right and Randy is right too. So I say yes and no.
No, Ranty is wrong.
Yes,
I'm right.
they both have a point.
No,
Right.
we don't.
Well, anyway.
The effect is physical, but the light isn't.
Light is always physical. It's part of the physical world. It is it is stand out in the sun. Stand out in the sun for 3 hours and find out what happens. You'll burn.
Yeah, that's the
You'll burn.
effect.
Because
The
it's
effect.
because it's physical. If it wasn't physical, there could be no effect.
It's physical effect, yes.
But magnets have an effect, and the magnetic flux lines aren't physical, but they,
Yes, they are.
have an effect.
Yes, they are.
Okay, Brenda. Okay.
Electromagnetism is real. It's real.
Yes.
Of course, it's real. There's you're conflating what's real with what's physical and tangible. This is where our problem with you guys comes in from the very beginning. You've changed what words are supposed to mean, like level. You change the meanings, and you can't do
The
that.
most crazy
We haven't.
thing.
We haven't done that at
Level
all.
can
We haven't
give
done
us
that at
the
all. We haven't done that at all.
Yeah.
We have not done that. We
Level
have not done that.
is not curved. Light isn't something you can hold. It's real. It's not physical. There's a difference to those words. You know, this is why semantics is important. This is why definitions are important.
Level being
You know, you
curved
got-
was defined in the 19th century. What are you talking about?
What are you talking
Level
about?
is horizontal.
No, it's not.
Horizontal.
No, it isn't.
Yeah, it
It's
is.
level is a local thing. It means
Look,
it means
Level is having
equidistant-
no part higher than another. A curve always has one part higher than another. They
Curves-
cannot be the same thing.
curves are level because they're equidistant from
No.
the center of the earth.
No,
Yes, they are.
no.
Yes,
That might be your.
it's from the
That might be
19th.
what you.
It's from 19th century surveying textbooks.
And that's what I'm telling you. You've changed the definition of what words actually mean to
Something
fit
that's-
them into this
Something that's
curve. A curve has one part of it. The curved line, there is a part of that is higher than another part. A horizontal line, a level plane, has no part higher than another. So if you say a curved line is horizontal level, then you're saying a curved line doesn't have one part higher than another.
So this definition is from like the 19th century, which is like over 100 years ago. So
You're not
actually,
addressing
you're
what
the
I
one.
said, Brenda. You're just saying
You're
the
the
same
one-
thing again.
Yeah, you're the
Just
one.
because they did it
changing
100
things.
years ago doesn't mean they've changed. They still changed it like for thousands of years.
No, they
Flat,
haven't changed
level,
it at
horizontal
all.
all meant the same thing, and then
No,
all of a
no,
sudden
they
you guys
didn't.
come along with your ball.
No, it didn't. It
Yeah,
didn't.
you did.
You're
Does a
just
curved
wrong.
line have one part higher than another? Does a curved line have one part higher than another?
Compared to what? I mean, what does that mean?
Itself. Like if you were going to tell a child what a curved line was, would you tell them that a curved line had no part higher than another?
That
So
if
we're talking about.
comparing a
Hey,
point to
please don't
another
let
point.
it. Don't interrupt. Just let it. Please let the silence just go. If
What
So
silence? If she cannot, find the words.
thanks for that.
I hate.
Yeah,
to
just
say
let
night-
the
night- white
silence.
knight.
Just let it be. Don't jump in. Let her have her.
Everyone jumps in, so why don't I?
Oh.
Because I have something.
And I'm
to say.
asking you not to.
Why would I listen to you?
Because Brenda and I are having a perfectly good discussion. There's no need for you to jump in. Just let her answer in her own time.
I'm helping
As long
with
as
a
she
better
needs to
explanation.
take that.
A simple
Well,
example.
she doesn't need your help. She's smart enough to answer these questions on her own. Thank you.
Are
I'd
you
like to
upset
hear
with me,
Crow.
Brenda?
Yeah, go ahead, Crow.
Yeah, she doesn't want to answer.
I was saying that there is a point higher than another point comparing to that point, but what Brenda is saying.
And
that
on a level line,
comparing-
there isn't.
On a level line, yeah.
There's no
because-
part higher than another.
Exactly, you're right.
And on a curved line, there is.
Comparing to a point.
No,
another
don't
point
compare
could
it
be
with
higher
anything.
or
Compare
lower.
it with itself. If you were going to tell a child what a curved line was, would you tell them that a curved line had no point higher than another on it?
Comparing to which point?
Don't
Okay, I get your point. But in general, when we're talking about curves, we're not talking about just any curve on a paper. We're talking about the curvature of the Earth, and that's measured from the center of the Earth. So there's no point higher than the other on a ball.
And that's where we're trying to tell you that you have taken what is a flat plane and then wrapped it around a ball and taken it to the center of the Earth so that your level is level that's curved. But we're trying to explain to you that's not how it works.
Nobody took a flat plane.
Why?
Right.
Yeah,
got
it was always flat
level
for
22,
thousands of
for
years,
example.
and then they wrapped
No,
that
it
around the
wasn't.
ball.
No,
Would
the
we,
globe
yeah,
has,
so
the
every
globe
Every
has
ancient
been,
civilization thought it was flat.
and people have known the globe is round for 3,000 years. So you're wrong again.
Yeah, that's not very long. We've been here for way longer than that. Like, that is like a 1% of the time that we've existed. That's like a drop in the ocean, that amount of time. It's nothing. I mean, they have watches now built on the Antikythera mechanism. $350,000 for this watch with that has the whole Antikythera mechanism on it. And that's all based on geocentric, the little earth things in the middle, everything goes around it. There's your predictive model.
I would like to see a verified statement that is from 3,000 years ago that someone's found, indicating that any civilization just came right out and put down somewhere. It is absolutely a sphere. If you could show that, that would
That's
be
how
great.
it was taught. That's how it was taught.
How do you know
Well, we've got people that are 100 years old saying they've been taught flat.
You can't know it was taught unless it was written down somewhere. You're saying that they said those things, you weren't there to hear them. So where was it written so we can read it? Where's the paper or the stone or wherever it was put so we can see it for ourselves that that's what was taught?
There isn't anything.
I didn't
they
think
just
so.
want us to believe them. They just...
There's
this
no
is
actual
what they were
proof that
told,
people
so now
thought
they're
or
telling
taught.
it to us. Yeah.
No,
Yeah.
it's what people have been taught, educated people.
Yeah, and just as
Obviously,
soon as you
Yeah,
show
we're
us
asking
a
to prove
verified
that.
piece of paper or stone or something where it was written down,
Anything.
then that's cool. And until you show that, it's conjecture, fantasy.
no, it's not conjecture.
Well, I said what I said.
Well, it's not proof, is it?
I bring
You
something
haven't
up.
given any.
I present something, Ranty. All right.
Yeah,
sorry.
who's...
Sorry, what
Go
did you
ahead,
say?
whoever that is.
Sorry, what was that?
It's Chris. I was going to see if I could jump in and present something.
Yeah, of course you can, yeah.
Actually, on this Discord, I don't really have to do is
Okay.
share your
So you
screen.
you can screen share. So if you go to the show channel, obviously, down at the bottom, you'll see you've got video and screen right above your username at the bottom. So if you say screen, it says share your screen. Click that and then choose which one you want to share. It gives you an option.
All right, so I'm going to screen share this. So I've been doing some sun tracking tests, and what we hear all the time from the ballers is that how many degrees per hour does the sun rotate does the sun move in the sky? And every time they say 15 degrees, right? They beat that into our heads. 15 degrees, 15 degrees, 15 degrees. In fact, that's actually not correct. Not only is it not correct to us, it's not correct in the ball model. You have to take in your latitude into account, apparently, and you have to do some math. And depending on your latitude, you actually get less than 15 degrees oftentimes. 15 degrees would be literally if you're like on the quote-unquote equator of the ball Earth. You would get 15 degrees. But so I thought, well, that's interesting. First of all, it's not 15 degrees, so that's just false. And second, I thought, well, what would happen if I actually measured the sun myself? So I did that, and I'm actually doing it. I'm probably gonna have to take about 5 minutes, go out and take my next measurement. But I'm gonna screen share what I've done so far today. So I went and got a protractor, and I set it up. I set this thing up to where it's gonna cast a shadow on the protractor. As you can see, there's 3 images, each 3 hours apart. On the left, it's obviously starting at 0 degrees. Can you see this, by the way? Picture.
Yes, we can,
yes.
So on the left, I obviously set up the edge of the shadow to be right at the 0 degree mark. So that's hour 1, and I have a timestamps, 13:51, so 1:51 Central my time. Hour 2, 14:51, 2:51 Central. If you look, you notice it goes to 10, 11, 12. And it's actually, I would say it's not even, when I looked at it, it wasn't even on the 13 degree mark. I would say I will give it 12.9 degrees change. Problem is, my latitude, if you do the math, I'm supposed to get 14.4 degrees of sun movement. So not only am I not getting 15 degrees, I didn't get the required 14.4 at my latitude. Now, if you go to picture 3,
it looks like it's close to 14 in the middle picture.
Have you seen
less than
Nathan's
It's
Nathan
like
and
13.
yeah, sorry, can I just finish real quick, and then we can have to go out and do my next measurement. I just want to cover the last image. So another hour, so 15:51, 3:51 Central my time. Got 20, 25, 6, 7, less than 28 degrees. I'm supposed to, at this point, hour 2, I'm supposed to be at 28.8 degrees, which would be somewhere over here. So it didn't catch up. I'm still shy of 28 degrees
Looks like it's
by
close.
this shadow.
Looks like it's close though. The middle image is close to 14, which is what you said it should be.
Oh,
And
we
then-
don't
then
work on
doubling that,
It's below 13, Brenda.
and then
Don't
doubling
work on
that,
close
doubling that
Brenda.
would put it
Model.
at 28, which
Yeah,
is
your
about
model's
where it
wrong.
should be.
Brenda, you need to redo
You
your
said-
model, Brenda. I'm
You
sorry.
said according to your latitude, it should be about 14.
14.4.
almost 14 and a half. It's not even at 13. I'll give you 13. Now we're at 1.4 degrees off. In the third image, you should be at 28.6, and you're less than 28 degrees.
Well,
Nathan and Antonio and them did a sun tracking thing and found time and date was like half an hour to an hour off. In lots of
Chris, have you ever
I
done-
would imagine
have
that.
you ever looked at the equation of time while you do your findings of the period of month we're in, and the period, obviously through the week, the day, the month, and look at the equation of time? Have you compared your results to that?
Talking to me?
Yeah.
Oh, this is like today. I'm literally doing this today. This is the first set of
That's what I'm saying.
tests
I'm
I've
saying
done.
you can go. There's an equation of time chart you can go and use, and it's based on man's construct of 60 by 60 by 24. What the equation of time does is will show you exactly what you're demonstrating is the acceleration and deceleration of the sun movement, and it's established already. It's called the equation of time. All you're doing is substantiating the
How does the sun
acceleration.
accelerate and decelerate?
Based on its path, the height of its path and the movement of its path. So
No, I don't think it. I don't think.
according-
I
don't
think
that
you would
happens.
find they would say that's the Earth's rotation around the sun that's
Exactly.
elliptical and going slower or faster. It's got nothing to do with the sun moving in your model.
no, exactly. It's basically showing us that it's the Earth is flat and it's the sun it's moving in an elliptical path around Earth. That's what the
No,
equation of time
the
to me
Earth is
translates.
moving. The Earth
Oh,
is
right, I
moving.
get what you mean.
So
The Earth moves in an
it's
elliptical
showing to
pattern.
me- it's
Yes, the
showing
sun
to
is
me-
moving.
Yeah, it shows to me, the equation of time shows me, based on man's construct of time, that the sun is speeding up and slowing down, like Chris is showing in the demonstration. That's all I just wanted to say.
Yes.
Yes, yeah, it is. The sun does speed up and slow down. It does. Like
No, well,
in
it's the
either
Earth.
model, we just say the sun and you guys say it's the Earth. Yeah, like yeah.
But Chris, the angular speed of the sun does not depend on the latitude. It depends on the declination of the sun.
It will actually calculate to the minute whether it's behind or in front, right? That's what the equation of time does. So it actually shows you the oscillation pattern, and it shows you when it gets close to man's construct of time and then moves away from man's construct of time. It shows the deviation.
Strange, because I concluded the equation of time before I knew that there is something even called the equation of time, and I plotted the solar analemma using these equations based on the heliocentric
So it
model.
shows you against. You have to realize the equation of time. The derivative of 60 by 60 is the observation of the sun movement. It's the
There's no
quantification.
such thing as 60 by 60. I don't know what you're talking about.
It's the
I've never heard
60
of that.
seconds, 60 minutes make an hour. What don't you know about 60? Are you serious?
Can you give us that
I'm
equation?
saying I made the equation of time on my own without knowing that it even exists, and I've never used anything
Wow.
called 60 by 60.
So, okay,
What?
so the thing is,
That's
you've
what
used,
you
That's amazing. He just made an equation of time himself.
yeah, he used
Yes.
the construct of
It's on
Unbelievable.
my
and then
channel.
he matched the sun
Wow.
time to the construct of man's time and thinks he come up with something. Buddy,
You are
the reason why
assuming
we
what I
have
did.
60 the reason why we have 60 by 60 by 20 is because we watch the sun. It's a quantification of it. What it shows you is man trying to quantify it to give you 24 hours a day. It shows you that it's sometimes earlier than 24 hours a day and sometimes later than 24 hours a day. That's reality. The 60 by 60 by 24 is a quantification of that reality. It's a construct. It's not actual reality.
Exactly.
So what? Anyone can multiply 60 by 60 by 24. So what? And where did
Yeah, but
does
he's
that
showing
take you?
that's the sun moves differently to that.
We have to add an extra full 24 hours to the calendar every 4 years because of this problem, right? We're not
Yes.
our calendar doesn't match reality. The Hebrews don't have that
The
issue.
time
The Hebrew
concept.
calendar and the Islam calendar doesn't have that issue. It's just North America that has that problem, and that's just something you should.
It's right.
Well, on round table 7, I've made a presentation about the solar analemma, and I show the equation that I've used in order to conclude that amount of shifting to the left or to the right, depending on the date. So, yeah, that's what I want to say. And Dave Marsh made an observation from London, and Jenna Friedel from New York. They were measuring the angular speed of the sun using cameras during noon, and it was not 15 degrees per hour. It was like 13.7, and that's the minimum speed you would get during summer or winter. If you want to know the angular speed of the sun, you just multiply 15 by cosine the declination angle of the sun on that date.
Really? Do you think the sun can be in a different elevation too? And different altitude? Do you hear me?
Yeah, we just didn't. He didn't come through very clear. Then it was a bit muffled.
I'm asking, just thinking about if the sun can be in a different altitude, elevation also. Just thinking about it. If the sun can be in a different altitude. Somebody?
A different height, like does the sun go up and down as well as around? Is that what you're asking?
Yeah, if it's in the middle of the earth, that is the highest of the North Pole. It's like in the magnetic electric field, they can be in a different altitude in the field. So it's not all the time in the same height. The sun can move up.
Yeah, I would think that them tilting the Earth and their explanation for seasons and stuff. If you think about that on a flat Earth, that might mean that the sun could be going up and down as well as around.
I heard they are talking about the sun can go in a pattern like an 8 in the
In
field.
an 8, yeah, the thing Crow shows on his little thumbnail.
Yes, it looks like an 8, but it's in the electromagnetic field. It's going up and down in a path of 8. It's something like that.
Yes, yeah, that's what it does.
The sun cannot go high and low.
Yes, it can.
Why not?
Because it's not physical.
Because in the
I can shine a laser light up and down on the wall.
You know, the arc minutes of the sun changes size, right? You know, in the sidereal information, when you're measuring diurnal motion of the stars, sun, and moon, it shows you the angular size of the sun changing daily to the observer. You realize that, right?
Yeah.
Yeah.
We don't see in the real sun.
so
There is
it
a
shows
apparent
you- it
sun. There is
shows you-
apparent light.
It shows you that there's an apparent size change, right? Your model suggests that the sun is 93 million miles away. And you're suggesting that the Earth is going through all these tilted motions. And through these tilted motions, you're changing the angular size of the sun, right?
But
Now,
it does.
there's an
Which angular
sun-
size?
the sun doesn't
Vertical
change.
or horizontal?
So as it moves away from the observer, it changes its arc minute. So its angular arc minute degree changes, right? This is
How-
measured
but how
data
much?
that you can look
No,
very,
not
very
right.
insignificant, very insignificant towards the data in sidereal, but it's noticeably mathematical. Or sorry, let me say it's noticeable in the math. You can see it changing the mathematics. Optically, you're not going to probably see that for the most part, unless you're using 50 mil with a heavy solar filter. You may see the sun size changes.
That's due to the Earth's orbit.
There is
Yeah.
no orbit.
So
on it.
No,
as
there
objects
absolutely is.
moving away, yeah, there's
Not
no
through the
motion
day.
of the Earth,
Not-
right?
Not through the
So
day.
you-
It changes through the year.
It changes through the year because of the Earth's orbit is elliptical, but day to
it's
day
changing daily,
it doesn't change.
okay?
No, it doesn't
So
change.
as it
It
moves-
doesn't change.
It changes daily as
doesn't.
the
It-
sidereal information.
No, it doesn't.
If it changes yearly, then it is changing on a day-to-day basis.
That's correct. So it's as it's moving.
You
through-
can't change yearly without it doing that on a day-to.
Unless it
Can
changes
you use
very
it?
suddenly and in a very big way.
Okay.
Yeah, unless it just does it on one day. Yeah.
I have a
It's a
question.
constant
Dan.
movement through its cycle. So what it's doing is it's going higher and lower in the sky through its season. So if one observer is in the north, he will see over the season the sky. The sun is lower in the winter and higher in the summer.
That's just
And it's an
apparent.
observable
That's
fact.
because of the tilt of the Earth.
So what you see is you see the sun grow closer to you, and as it gets closer to you, it increases in arc minute size. This is a sidereal motion that you can measure. It's already there inside Stellarium data. It shows you that it increases size. Your model suggests that the sun is 93 million miles away, massive, but yet appears to be the same angular degree size as the moon, and yet through the same cycles, you still have that apparent size change. Moon
The
is lower,
size change is due
moon
to
is
the
higher.
orbit. Is due to the elliptical
Does
orbit
that
of the
happen
Earth.
to the moon?
There's no motion of the Earth, my friend. It's diurnal motion. It's measurement of.
No,
it's
we
not
know
measuring
that the Earth
rotation.
is. We know that the Earth
No. When
orbits.
you measure, listen. When you do diurnal motion or the sidereal information, you're measuring the movement. You're not measuring Earth rotation. You're measuring the movement of the stars. the
I'm
sun
not
and the
talking
moon.
about Earth rotation.
You're
We're
not-
talking about Earth's orbit.
Yeah, we're not measuring anything with orbit. We're measuring the diurnal motion of the sun,
Well-
moon, and stars. We're coming
well,
up with measurements.
No, the
How
reason
we come up
that
with
the
those
reason that the
measurements,
sun
Earth
the
is-
reason
listen,
that the
how
sun's
it-
angular size
listen, how
changes
we
throughout
came
the
up with
year.
those information
We
is
know
due
what
to the
you
orbit.
say. Listen to him, Brenda. We know you're.
Stop interrupting. So the
How- no,
reason
you're interrupting me. You're not letting me get it out. So the point is that the study of that information is not using Earth rotation. Okay, don't study the diurnal motion of the sun and moon and stars by studying the Earth rotation. They study the movement by the Earth is stationary. Then they study the movement of the stars. That's how they get the angular size change. The angular size changes is based on its orbit. You understand? It's based on the rotation above, not Earth rotation, because there's nothing in the math that says Earth rotation. Okay, it's diurnal motion. It's measuring the movement of the sun.
diurnal
I don't know how it's more simple.
diurnal notion is
I don't know how it's-
apparent is the
Motion.
apparent notion is the apparent motion.
It's the study of the movement of the. It's not the study of the Earth. It's the study of the movement of the stars. Get that.
Right,
link
and
to
it's
that in your mind.
it's their apparent motion.
So when you go
I
look at the math,
I think it
And
can
then
be
look at the sidereal
two-dimensional.
there's no, especially when you study the Sun and Alima, and you look at the 1300s when the Arabics, they weren't studying Earth rotation.
Diurnal
When they were
motion is
studying the
it's caused
They-
by Earth's
They weren't
rotation
studying the
about
Earth
its axis.
rotation in the 1300s, fellas. Okay, there was no study.
It's
in the
caused
literature.
it's
There
caused
was
by
no
Earth's
study
rotation.
There was no listen.
Brenda's getting triggered. She can't let him even finish.
Sure, there's no question in earlier 1300s of rotation of Earth. Okay, it was still quantified as a celestial sphere that was rotating. Earth was stationary and geocentric. There was no introduction.
I don't
of
care
this
about 1300
math.
years. You
Listen,
know, 1300s.
It's very
Today-
important you know about it because
No, it's
you have
not.
to ask yourself why. Yes, you do, because you have to ask yourself why in the early 1900s did Einstein have to come up with special theory of relativity?
Relativity has
They
nothing to
already
do
had
with
evidence-
diurnal
if they already
motion.
had evidence of Earth rotation. There's no reason for the formula.
No,
They
it
didn't
has
have
nothing.
evidence, and they still don't have
Rotation of
evidence
the
today.
Earth
That's
has
why
nothing
the
to do with
theory
relativity.
is unproven.
The rotation of the Earth
What,
has.
Brenda?
Yeah.
Hush,
So
hush.
I'm
The
done
rotation
with
of the
Brenda
Earth.
anyway. Brenda,
The
you
rotation
just
of the
proved yourself
Earth.
an idiot again.
No, I didn't. No, I didn't.
Wow.
The
You're just
rotation
bad for
of the
humanity.
Earth.
You're
The
just bad
rotation.
for humanity.
Whatever.
Everything
What
about
the
you
rotation of
and
the
come,
Earth
this
has
is your
nothing to do.
personality.
What causes the
relativity.
apparent movement of the stars, Brenda? What causes it to be apparent that the stars are moving? Is it because you're in a relative, you're looking at it relatively?
No, it's caused by the rotation of the Earth.
That's what I'm saying. Why do they then say it's the Earth? Because they're saying it's relative.
What is the
Di-
proof
di-
for the rotation of
diurnal-
Earth?
Diurnal motion
I
is caused.
can't believe you
by-
don't get that. Wow.
Diurnal motion.
Brother, where
is-
is the truth for the
diurnal
rotation?
motion. Diurnal motion is caused by the rotation of the Earth.
Where is the proof for it? Where is the
Study
proof
of
for the rotation?
Stars, not the rotation of the Earth, buddy. Get your
Yeah, why would you see stars moving and then say, oh no, that's the Earth moving? That's silly.
Because it's actually it is the Earth moving and not the stars. It's simply an
It's not,
apparent
though.
motion.
Okay,
It's simply an
okay.
apparent motion.
of the Earth. They studied the
Apparent why?
Because we're on the Earth and the Earth is turning, and so therefore it looks like
They did
So
not-
what's that
objects-
called?
they did
that's
not
called
study
apparent motion. That's called apparent
Yeah.
motion.
rotation.
No, you're squirming now.
1900 they started studying rotation of Earth, Peckerhead. 1900s. There's nothing studied of rotation prior to them, dude. Einstein was the savior of it all, so they could push
Kepler
forward.
did it.
They're
It was Kepler, not
Kabbalistic.
Einstein.
They're
Mhm.
Kabbalistic. There was no proof, dude. There's no experiment.
Relativity has nothing to do with
There was
diurnal
no
motion.
experiment. All it was the study of the movement of the stars. This is a fact.
Yeah.
There was no
Diurnal motion
quantification
has
of
nothing to
rotation.
do with the
Yeah,
rotation of
you
the
can't
Earth.
Keep on saying it won't change the fact, Brenda. Just move
Show me
on.
literature,
Yeah.
any
Stuck
do that.
record.
Okay, I just want to say, Flat Earth Data, your mac's a bit low. I've put it up as much as I can, but there's nothing more I can do.
I don't know what to tell you, bro.
I'm listening. I'm hearing a weird term. I would like someone to explain it to me.
It's
Di-
good enough, but it's not. It's
Di-
not great. Go ahead, Crow. Sorry.
Diurnal speed. What was that? Diurnal rotation.
Diurnal.
What is that?
It
Two
means to-
urinals. Diurnal.
No, it has nothing to do with urinals. It has to do with it. It means it has the root in day, so it means the daily motion, the
Night.
daily apparent motion,
Oh,
the daily apparent motion
okay.
of celestial objects due to the rotation of the Earth.
Oh, okay. Thank you.
And to prove that, you would have to stop the rotation
I
of
took a
the
shot.
Earth and make sure, using the scientific method, that that's what was causing that effect. But you can't, so you don't have any actual proof.
So says you.
Well, I think by common sense.
No,
if
so it says
everything-
science. You must
everything-
control your variables, independent variables
I
and shit. You can't just
What if we cannot
observe
control
and
the
declare.
stars?
As
We
an
have to
astronomer.
resort to other methods. If we cannot control the universe, then we have to find other ways.
Yes, but that's not. You're then just correlating. You're not actually proving.
Well, one way
What
that
do
you can
mean
prove
correlating?
one way that you can prove that it's the rotation of the Earth versus, say, the rotation of the objects in the sky is by the use of Foucault's pendulum or Bob Nodell, 15 degrees an hour, fiber optic laser.
Blah, 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 blah.
No,
Yeah.
it proved it.
So I just
Bob Nodell
So
proved
funny.
it. He proved it. He
No.
proved that the Earth rotates.
Rotation of the Earth. The pendulum left. the
hold on,
rotation
because
of
I
the
just
Earth, right? Give me a
I
break.
just did a measurement and I'm not getting 15 degrees per hour, Brenda.
Oh, that's brutal, that one. Mind you, what time's that? 16:55. Is that were you 4 minutes late on that?
Are you talking about the one I'm screen sharing now?
Yeah.
So this is very odd. So again, to be fair, it's my first day, so I'm gonna put more stringent controls on this. So at 15:54, I reset it to 0 because I wanted to line everything back up. Then I go back out an hour later at 16:55 on the right, and it's showing almost 21 degrees movement. So I can't reconcile that. And I thought, oh God, maybe like the wind blew it over, or the dog knocked it over. But if you look at the setup hasn't changed. So it's sitting on top of this thing, and I placed some rocks. Like there's a brown rock here next to the point of the protractor. There's a brown rock, the same brown rock here. So that hasn't moved, not an inch, not a millimeter.
Did you say 21 degrees?
21 degrees, yeah, in 1
So
hour.
Wow.
So Chris? What's this timestamp?
That's preliminary. That's
Chris,
preliminary.
I can
Chris.
see the timestamp. So let Brenda, I'll tell you.
I don't
So
see it. I don't see it.
I can see it. It's 15:54
Right
on the middle
here,
one,
and this
and
one's right here.
and it's 16:55 on the next one. So.
I turned this picture on its side. I took it from from a widescreen angle because I thought I thought, oh God, I knocked the thing got knocked off, or it moved. So it would have had to have moved several centimeter or millimeters or inches, half an inch or whatever over. But I'm looking at it and I don't see a change. The thing it's sitting on is like a little cup. There's a gray rock right here, and that same gray rock is still there, so it hasn't moved. So I'm kind of baffled by this, to be quite honest.
Well, I think there could be a more accurate way to measure the angular speed of the sun.
Well, rather
I don't
than using
think so.
shadows. What, rather
than using shadows, which will be perfect.
With
So
shadows,
Eratosthenes was okay, and you'll use that as proof, but
And by the way, I was using a Theodolite app, and someone told me to go get a protractor. One of the ballers told me that. So this is actually an improved process that I'm implementing here.
okay,
The recommendation of a ball tard.
Let me give my proposal. If you don't like it, then do it. It's very simple. You're going to use a pen as a gnomon. Just put it vertical, and tie a thread from the tip of the pen and to the tip of its shadow, and then wait another hour, and do the same thing. So you have two threads with a separation angle. Then you can picture this angle of the thread. And
why doesn't this work?
yeah, he's done better than that. He's put the protractor there already. So you're saying take away the protractor, put two things, and then measure it with a protractor after.
Add a step.
The protractor's broken. Wait a minute, the protractor's broken.
No.
Oh, it's got to be.
Yeah, it's definitely broken.
No, not the protractor. It's good.
So
But
it's right then.
which
So it is
angle?
What's the
Like,
problem?
look, the pen in the next picture, the one on the right, is taller. So there's a component to the angle going up, but he's not measuring it.
What are you doing?
Oh
Hold on.
Same.
The shadow moved to the right and up.
It's pretty blatantly obvious what it's showing. I mean, everyone can see that it's moved 21 degrees. But listen, how about doing a live stream of this tomorrow at the same time when you've got this big jump? So if it's the same sort of time, you might be able to get that same if you do a live stream of that.
Yeah, I probably can't do a live stream, but I could try and record it.
Yeah, that might work. Yeah, you just record it and then just just speed it up with put a clock.
Because if this is real, let's say there wasn't, I don't know, I'm almost, when I first saw it, I was like, oh God, like I said, something happened, the dog knocked it over or something. But I brought up these two images and I'm comparing them. I'm like, I don't see any difference. There's nothing that's changed. So yeah, if I'm almost kind of hoping that something messed up, because this could be insane, right? The amount of angle change due to the shadow.
Get a bit of echo, by the way. So somebody's got the mic on.
Somebody's
Oh,
yes.
damn, it's me.
So yeah, I mean, if you could do it, if you could record this and have like
This is preliminary. Look, yeah. Look, this is preliminary, right? I'm making that session, so I don't know if something happened or what. But I'm gonna do this again tomorrow for sure. No, like I said, I'll shore up the setup and I'll do my best to record it. I only see the only problem is I only have an iPhone, and so I don't know. Can you record on an iPhone for an hour without it like getting overheated or getting out of storage? That's my only concern. But I'll see what I can do. So.
Okay. It just might be. It might be worth doing. I mean, I know that you've got the images with the timestamps on, but you know what these Globers are like. They won't believe it unless they actually.
And that's why, in fact, I use the Theodolite app that I have, and the only reason I use that instead of the normal camera is because it put the timestamp on there. Otherwise, I didn't know how else to do the timestamp. And then putting, like a watch next to it, which I didn't want to do. So the timestamp is from my iPhone. It's synced with the clock on the iPhone, obviously. So that's why I use that Theodolite app, which is why you see the crosshair in the middle. There's no other reason for the crosshair and everything else. I just used it for the timestamp. So I reset it up. So I reset it to 0 because I was like, okay, something happened at 4:55-ish or whatever. Oh no, yeah, exactly, 4:55. A couple minutes after that, 4:57, and I'm gonna go back out again, and an hour later, and do it and take another measurement and see where it's at.
Can I ask what does this mean? If it's Suki Greeks, what is this about? What is this about? Sean? 21.
I don't know what it would mean. The only thing I can definitively say is with almost certainty now, after having done this a couple of times, is that the sun does not move at 15 degrees per hour.
Really? Are you saying it's moving 21?
Can you use the Theodolite to? Yeah.
I'm definitely not saying that. Like I said, this measurement is fishy, so I'm gonna double and triple check it. Do it again tomorrow at the same time.
Well, all you're doing is some science, and you're reporting what the information is. That's the information. Let the people decide about it.
That's right.
I just want you to be careful of one thing. Where is the shadow moving? Is it moving like around the center of the protractor, or moving into another direction?
You're
Point of the protractor to the right.
Super low volume.
Hello, can you hear me now?
Oh, not you,
Yes.
the other person.
Okay, so if you take like 7 hours, is the shadow of the pen is not going to be the same length, right? And this means that you are not measuring the whole angle.
The only place you. Go ahead, Chris. Sorry.
George Natchik in chat says the sun arc trace changes when you project it onto a horizontal plane. So what he's saying is we can't use sticks and shadows to measure anything because it's going to be
Exactly.
I don't think that's
based
what he
on
says.
the.
I don't think that's what
Not
that
how it
means.
works, Chris.
So how does it work, Carlos?
Globe.
You don't just grab one thing and say, oh, because of this, and you can't do that. Same thing.
That's what George is saying, Carlos.
That's what George just said.
And you said he
how do I
can't
do it?
do that, so thank you. No, he can't do that.
George didn't say
you very
that. He didn't say that you can't use the shadows for anything.
The measurement
he
of the
say?
angles of the shadow is not the same as 15 degrees per hour. We're measuring two different things. One is triangulation, the other one is rotation.
So how do I do it, Carlos?
Not this way.
It's
He doesn't know,
morning.
but not this way.
hey, good
Hey, Ranty.
morning, everyone. It's Aaron. I just tuned in, and I just
I
got a
think
quick
you're
question.
roboting.
Okay, go ahead.
Sorry, could you not hear me talking?
Yes.
Okay. No, thank you, guys. I just have a quick question. Am I still roboting? Sorry, I just sneezed.
No,
That's
you're
the
not.
sun.
No,
Are you
no,
there?
you're not. You're not roboting.
Yes. Yes,
You're not,
we're here.
You're fine. You're fine. Go ahead.
Oh, cool. I just had a quick look at that picture. I'm not sure who was doing the measurement with the shadow, but on my phone, there's 3 photos going from left to right. The middle photo shows it at 0 degrees, and the far right photo shows it at exactly 16 degrees.
Yeah, that's the left-hand
but
side of the shadow. That's the left-hand side of the shadow that you're looking
You
at.
have to use the right-hand side.
You have to use the right-hand part of the shadow, because the right-hand part of the shadow is on the 0, and I've got an echo again.
Oh, okay, cool. No worries.
Bro, you
My
gotta
fault.
mute me.
All right.
And the right-hand side of it is at just after 20. I'd say close to 21.
All right, so George is saying I can't do it this way, right? So, all right, George. So
You're
how do
not
I
allowed
do
to
it?
use shadows. You're not allowed to use shadows. Well, they were allowed to use sticks in the ground with shadows.
Yeah, he's not saying that you're not
Yeah,
allowed
it's
to
okay
use
for them.
shadows. He's not saying that at all. He's not saying
He
that.
said, all right, let me read
No,
what
but
he
that's
says.
the implication of it.
Let me read what he says. He says, no, that is not correct. On a stick shadow projected onto a plane, the time on each hour traced out on the plane changes between hours. Later in the day, the hour spacing gets closer. So
Yeah.
So how do we measure the degree per hour of the sun then, guys? Come on. This shouldn't be this complicated.
You know, Chris, the funny part is when you researched equation of time, that's exactly what they did. Is they studied the shadow movement.
stole that.
They studied the shadow movement based on the quantification of 60 by 60 by 24. So George is out to lunch.
There's no.
So
what is 60 by 60 by
tutorial
24?
mount about that.
60 seconds, 60 minutes, 24 hours. Oh my goodness.
Yeah, none of these are measurements.
Is my voice low?
When you start dealing with angles, you don't prove shape or measurements because they can happen on a circle, on a ball, on anything. So all you're doing is tracking an angular. You're not tracking a distance, which will give us a measurement, which will give us a shape.
Angles can easily describe shapes. What are you talking about?
Well, we're talking measurements, not shapes, okay? So in order to have a shape, you need to measure the outside of it, okay? So you can't tell me you measured a square and I say how long are each side and you go 15 degrees because that's not a measurement of distance, so you'll never get the boundaries of the object measuring angles, okay? And this is what the ball earth has to do.
I have no idea what you're talking about.
Why did he just get muted?
He's not muted. He's not muted. I don't see any mute on anybody.
It seems like that tends to happen
just
with
dropped.
him, maybe for some reason.
Yeah.
That's the thing, though.
Nobody's
When you do
muted.
the shadow
What are you
with the
talking
sticks,
about?
you're
Nobody's
actually
muted.
using length.
Nobody's muted, no.
Carlos is quiet.
Yeah, no, you can, the shadow,
Oh, there you are, you're
thing,
back now.
especially when it's like 14.4, 14.6, like, it's all different all over it's not.
Yeah, if I said to you, Chris, I've got a 15 degree angle here. What shape is it inside? Do you know?
Come on, man. How are you gonna know?
Yeah.
It makes all the angles do. They all make one thing: a circle. Okay. Now, whether that circle is being viewed from a flat stationary plane, or whether that circle is you on the circle as it moves, you know what I mean? Either the sun makes the circle, or you're making the circle. But all you're doing is tracking a circle. You have no idea what size that circle can be.
But
You don't think it's weird? The only method we have to measure the Earth is this angle stuff.
No, that's not the only method we
don't have anything better.
We have lots of methods.
They
No, you have
stick with the angles because it's malleable. They stick with the shadows because it's deceit. You can deceive with them. That's
Yeah,
You
exactly.
can't- How do you deceive with shadows?
'Cause
Yeah,
if
I'll tell you.
take a
I'll
straight
tell you
line-
how
I'll
you
tell
deceive.
I'll tell you how you do it. You take one straight line, okay? If that straight line has no curve to it, you're going to have a 90-degree perpendicular between two ends. If you shine a light on those two ends, they're going to produce the same angle. If you change the straight line into a curve and you have one that's 90 degree and one at 45 degree, and then you shine a light, they're not going to match the same angles. That's how you do it.
What the fuck are you talking about?
George says you
Ooh,
can measure
first
it.
word from Brenda.
I clearly just
Good.
told you what it is.
Wait,
I think
wait,
you made a little bit too much sense. And
No,
George,
I just talk like so. Are curse words not? Because some channels don't want curse words. Is that
Why are
not
we
okay?
talking about curse words, bro? Talk about what I
because
no, I
just
didn't
said.
say it wasn't
because-
okay. I'm just pointing out that you just happened to be the first one
I
to
just-
lose
I just-
your temper.
I'm not. I didn't lose my temper. What are you talking about? I just
Sure sounded like it.
It's just talking. What are you talking about?
Yeah, what letter data said made no sense to me either.
Take a straight line, two poles in them. They're going to produce 90-degree angles. When you shine a light, these two poles from separate distances will produce the same shadow. If you have one that's 90, one at 45 degree, which on a ball you must, if you have two poles, they're not going to be perpendicular to each other. Therefore, produce different angles along the same line, which isn't reality.
Oh, but then you can use that difference in the angular measurement, to calculate the circumference of the Earth, and that's what Eratosthenes
Not
did.
along the same longitude line. Do you
But
know why it doesn't work along the same longitude line, Brenda?
It doesn't matter because
Do you know why it won't
we use
work along the
multiple.
same longitude line, Brenda?
It doesn't matter because
Do you
we've
know
used
why
multiple.
it doesn't work along the same longitude line, Brenda? Or no, you don't know why.
We used
Tell me the difference
multiple.
between two pieces that are 90-degree perpendicular versus one that's 90 and one at 45. Will they produce the same angulars along the same line or no? No, they won't.
So Sly
So,
Sparkane
Brenda-
used over
Brenda,
20 different
I
people.
just gave everybody a simple example proving that one pole at 90 degree, one pole at 45 along the same line will not produce the same angle. Okay? It's really that simple, man.
Right. So you use
And now,
multiple.
according to George,
you use
according to
multiple
George,
observations.
if you use a shadow and cast it onto a plane surface like Eratosthenes did, then it's just not going to work.
Hey, Ranty, I was going to show you something really quick. Can I share my screen?
Of course, can you?
So I was messing around with Blender again, and I decided to take Pontchartrain into. So this is awesome. Let me just start over here to show you what I'm doing. Let me know when you're up and running here.
Yeah, that's fine. Yeah, we're showing.
Okay, hold on. Maybe I'm behind.
Yeah, I'm presenting. It's a 30-second delay on YouTube, so.
Okay, so let me just delete this and go new. So what I've done here is you can download a beautiful feature for Blender, and it allows you to get straight on 90-degree shots anywhere in the world you want. And basically, this is Pontchartrain. And so what I wanted to do is use this little feature to show you. If I grab this little data here, it's the elevation data. And
yeah.
This elevation data will show you. Now, what I'm going to do is I'm going to exaggerate if it lets me, if it's not glitchy. Sometimes it's glitchy. But if it will let me, I might have to reload another one up here. Let's just see if I can change.
It's weird how it's presenting it on a flat plane, isn't it?
Okay. Yeah. So here I'm just
Not really weird at all, is it?
I'm just being really exaggerated here on the elevation information here. So I've just I don't know if you can see it there. I've really exaggerated it.
Yeah.
Here's what's something really cool about Pontchartrain. So it's flat, but you see where the construction humps are?
Yeah.
Those are the construction
Oh,
humps.
wow. Yeah.
I wonder if Soundly's just zoom in on one of those construction humps from a long distance
Yeah.
away. And all this is exaggerated. Let me just bring down back this exaggerated stuff. So I'll lower the elevation here, and it's completely flat, nothing to it, right? But if I raise it up to extenuate, you can see the little.
So you're changing it.
He's exaggerating it to show us.
Yes. That's called line. That's what
But
it's
it's
called.
weird that the
No, he's just trying to show how it's not
Check it out.
flat.
Really
Oh, God.
exaggerated elevation data. Look what happens
Yeah.
to the bridge.
Yeah.
So it
That's
does
called
grab the data.
that's
That's
called
really weird.
line. That's called
So
line.
they presented it on a flat plane.
So are they lying about it being flat?
The bridge is flat except for the humps that they go over.
Yep. And they show you the humps.
See that.
So
Yeah, that's pretty cool.
this is called CGI.
Yeah, Brenda. It's called elevation data, which I'm exaggerating to show you there's no curvature over 15 miles. It's flat as fuck.
Yeah. So you've
you go.
cranked up the vertical
Elevation
scale.
data, yeah.
You've cranked
Yeah,
up
so
the
if there was
vertical
any
scale.
curvature there, Brenda, it would be so exaggerated at the moment. But it's not. The only thing that's exaggerated are the different heights of things. There's no curve in there anywhere.
Elevation data. That's
Yeah,
it.
this is elevation wouldn't
Do you
show
wanna
curvature
try another
because
place,
elevation.
Randy? Any other place you want to try?
Exactly, because elevation has nothing to do with curvature.
Right,
That's
because
right.
elevation is the mean distance above sea level, right? So it wouldn't show curvature.
But it wouldn't present as flat, though, wouldn't it?
Oh no, it would
Yeah.
present as
Look at
flat. It would present
Oh,
as
it would
flat.
now?
What,
It would?
the-
Elevation
You
would
have
be.
to then wrap it around a ball. It doesn't wrap around a ball itself. You do it.
No, that's what elevation means. It means a certain level above sea level, and sea level is level with the
Look at those little
with the
humps.
surface of the
Now
earth.
it's level.
The
Okay.
Yes.
question would be
Level with the surface of the earth, not
if we have
from the
if
center
we,
of the earth.
Too
if we
funny.
if we did the same exaggeration with Google Earth, is the Earth radius going to shrink in order to show curvature more apparent?
So you realize what this is, right? Like, I'll demonstrate it again, okay? Just so you know.
I
Let's
saw
go
it.
from scratch.
It's very
It's
clear.
gone,
Okay.
it's gone over their heads. It's gone over there. Well, or they're just blatantly ignoring it.
What place?
they're
in the
blatantly-
world
No,
do you
I
think-
understand it
Oh,
perfectly.
Blender
he's
crashed
he's
on me.
he's
Hold on
using
here.
he's simply cranking up the y-axis
Elevation data, yep.
in the elevation data. Yeah.
That's right. So I crashed it. I just have to reload it here. Randy, any other place you want any other place that you want to look at?
Currently, no. I mean, Lake Pontchartrain is pretty cool because Brandon, Toy, and myself are going to be doing some little tests on that. Well, not on that, but trying to recreate things inside the fish tank to emulate what's going on there. So, yeah.
Right. Well, we want to see the salt flats or anything like that.
The Bolivian salt flats, yeah, that'd be pretty cool.
Who knows how to spell that? Let me just see here. You know how to spell Bolivian?
Bolivian.
Salt flats. You know what's funny? I was doing this yesterday, looking at the largest lake, which is in Russia there, and really weird anomalies were happening with this data. It wouldn't give me to the location, and when I tried to do a section of the largest, the largest part of it, it wouldn't show me the data. So I just found it interesting that for a world,
Have you
full of,
tried looking at like the North
time
Pole
and
or
espionage, I can sure look at
Antarctica or something?
all the elevation data all around the world, man. Right? So there, I don't know if you can see the Bolivian salt flats now, but I have them up.
Yep.
Yep.
Section of it. Let's just get the elevation data. Now, what's really cool about this feature is you can actually add maps over top of it, clearly showing that there's no curvature whatsoever. Let me just bring up some of the information.
You do realize this is going to trigger the globe as no end.
Well, it's just
Yeah.
why would
at that salt
an elevation map show curvature?
Look at that.
Because it
Look at
should
that
be
salt flat.
curved render in your little
Why?
model.
Why?
It's
Because
the same
why?
elevation above the center of the
Ranty, I'm gonna
circle.
I'm going to show
No.
you this here.
Elevation
show
just
you
means
another one.
just means equidistant from the center of the Earth or from
Exactly.
the center of the geode.
Which will
It's
give
actually
in your
what it
model
means.
a curve, and these aren't
No, it
presented as
won't,
curves, are
Toby.
they, Brendan?
No, it won't. No, it won't.
Oh,
They're not
oh,
presented
what's
as
that
there.
white thing?
What I've done here, Ranty, is I've actually made, I know this may look silly at first glance, but I made an observer's dome, if you will.
Oh, right.
So now this is exaggerated. Basically, all I've done is turned it into glass and basically made a sun move over top of it.
That's
Oh,
pretty
wow.
cool.
That's cool.
To be
Yeah.
honest,
You can see
this is
that.
how I'm sort of envisaging it myself.
Yeah, so basically, I just wanted to show that as things move away from you, they appear to move downward. But because the atmosphere above is going to have refractive properties, it's going to look like it's bending downward, right? So I just wanted to show this and this actual circus, this actual circle is the size of this dome is actually based on the 3-mile radius of the observers.
The circus was more accurate.
Well, because the best part about it, bro, is what's going to come following these videos I've just posted. Because this is actually, if the observer was standing on the shore, I don't know how well this translates. If this observer was standing on the shore, you can see the circumference here. This is actually the circumference of the observer's view. In other words, if we were looking above the observer, looking down, that observer in that position would see the apparent junction of the sky at that circumference size.
I think there's
right?
probably a different. I have a different idea of what this would look like, but the thing's similar. But you'd have you'd start off at 3 miles at the bottom, but as you go higher, you would extend it, so it'd be like an inverted.
So how
you definitely above the horizon, I would say 10 degrees. You can see probably 16 miles, I think.
So
before it
how
actually
come
starts.
how come it looks
Can
like
you show the light source?
How
Can
come
you
it-
show the light source?
The light source is the sun. How come it looks like an oval?
No. In this simulation, can you show the light source and its movement?
In this simulation, the light source is the sun.
Hang on one
The
sec.
light source is the sun.
So yeah, the light source is the sun, and that's what it's shining off. It's like shining off what you see, which would be the atmosphere. So the atmosphere, you know, when I'm talking about, you'll see the lensing from the sun with the real sun behind it. So to you, that's what it would look like. It's your personal little area or dome, so to speak, your atmospheric dome that's around you, and that's what it would be reflecting off.
I get that, but I just want to see the location of the light source in this blender.
Oh well, that's just
Its
well,
movement,
it's
how
just the
it's- how
sun.
it's
It's just a quick model. It's not.
Is it moving straight across the top?
That's all it is going straight over the top, just like
Yeah.
a cycle. So if you go into use Blender for default, I didn't change the sun. All I did is do the animation for the rotation of it. So it's a default setting in Blender. Anybody can use it and go see. It's the same way I presented the last thing. I didn't add any sun or any flavor. All I'm doing is moving it past as if it's daylight, nighttime. That's it. And what I did is I added a personal dome, which everybody's already probably seen this example. But what I did is I wanted to turn it into glass.
So what is this supposed to show us? What is this supposed to prove?
So for
it doesn't prove anything, Brenda.
It can't prove anything. It's just a model.
You're right. It doesn't prove anything.
Models prove things.
It
Models
shows a concept.
prove nothing.
Yes,
it
they
shows
do.
a concept, Brenda.
Yes,
it's an
models prove
illustration
things.
to show you the effects.
No, models don't prove.
Yes, they
It's an
do.
illustration.
Yes, they do.
No, they
Models
don't.
prove nothing. You can make a
No,
model
they
of anything
actually
and
do.
make it work.
So
No,
Rachel,
they actually do
would you
show
like-
things. Yes, they actually do.
I have other
No, they actually
examples I
do.
can show you.
No.
They
Hold on.
literally
This
cannot.
looks like the sun is
They
going
literally
up
can.
and down under
No,
the model.
Listen, Crowe,
It's-
all
it's
it's doing is
Literally
moving
what
past
modeling
it.
is.
No,
All
it's doing a circle.
Listen, listen, bud. All it's doing
Show
is
me.
moving
Don't
past
talk
it.
to me. Just show
Calm
me.
down. Calm down.
Yeah,
Wow.
Crowe, actually, just learn.
What did
Blender,
you say
bro.
before, Andy? That this would trigger the boilers?
There's no
Show
sun
me the
here.
motion because you are doing it a circle
We're getting a
above
bit hot
and
under the collar.
Listen, bud. This here, I'm flickering off and on. This is the
Prove me
default.
wrong. Prove me
So-
wrong. Show
so
me the
listen.
motion of the light source. Thank
So it's
you.
the-
You're making it a
it's the
circle
default.
above and under.
It's the
Thank
default. Here's the motions. Here's the rotation.
He's
so
not
all
going
I've
to show
done-
you. He's not going to show you because he's
So
a
it's
coward.
rotating.
I'm showing you
So
here.
isn't that
Here's
what
the-
he's
He's
doing right now?
literally showing you right there. It's on the
There's the
screen. Look at
information.
it.
There's-
Right
there's the
there.
location.
There's no sun there. There's no sun there.
There's
We
the
want to see the
location.
sun.
No, the information.
There's
Can't
the
you
y-axis.
read?
We want to see
Location,
it. We want to see
rotation,
the.
mode,
the
scale.
We want to see the sun. We want to see.
Oh,
the sun.
because they can't figure out from its
Now I can turn this off.
location data.
I can turn this off and create a new sun for you. Would you like me to do that so we can position the sun in a place to show you the same example? Okay, let's create a new sun for you. Where's the sun at? Light. There's the sun. See that little dot? Or is it right there? Let's just see if we can move it. It might take forever to move it here. The right one. Sun.
This is garbage.
Oh, yeah. So this is a default sun. So it's going to be, it's not going to be at this position here. It's going to be above and you can see it's just a default position. I'll just brighten it. It just brightens over the model. See that? So if I just take the coordinates of it and if I do the rotation, it's going to either rotate this way or
So it's
rotate
rotating.
this way. So it's just, yeah, but that's all it is I'm just changing the rotation of the sun.
So it's not a straight line movement like on the flat Earth.
In the particular model that I demonstrated, it's just moving above the observer. It's moving
Right,
towards the
it's
observer and moving.
rotating.
Listen to me. It's moving above the. Moving
No, it's not.
towards the observer, It's moving towards the observer.
It's rotating above the
Right,
observer.
hold on. I want to intersect here. Just hold on, both of you guys. Right, listen.
It's moving
He's
towards the
just
observer.
started with his Brenda. Yeah, Brenda. He's just started with his model, right? So he's just putting things together and he's just putting the concept out. I'm sure it will become more refined over the next few months. This is just an illustration to show his early workings. And there's no need to jump down his throat about every single thing that he's doing, because I'm sure he will address it in time. This is just what he's showing you, what he's been doing recently.
Yeah, and we're just showing him where it deviates from the flat Earth model.
That's fine. You can show that, but there's no need to just be so ridiculously aggressive about it. You know,
Who's
the guy's
being
just
aggressive?
started doing. You both were.
And going on and on, saying the same thing over and over and over.
Yeah, I'd have to find out why this. Okay, there we go. So what did I do to it? Put it there instead. So just 0, 0. Let's bring it down. So I just have to figure out the direction it's going at. Let's look at the last one.
Looks pretty cool thing to be modeling, though. I mean, I wish I had software like this.
It's free.
Is it? Can you
free, and even that satellite information is all free, bro. All that stuff that I took is free.
It's called Blender.
So-
It's free. It's free.
Really?
Yeah,
Yeah.
it's all
Okay.
free, bro. And yeah, there's tons of tutorials online show you how to do this stuff. All of it.
So, is there a place that you can download it without viruses, though?
Blender-
downloaded. I both downloaded it. Yes, you can. Just go to blender.org, dude. It's free
Yeah,
right there.
yeah.
Blender.org.
Blender.org. Nowhere else. Just Blender.org. It'll be fine.
Just trying to match the same.
There's lots of free software on
light
the internet.
The limit of my software currently is with Paint, I think.
I think I had to move this crazy. I don't know. Let's just see.
Take your time. I know this thing is complicated. I tried to
It's
learn
no
it
what it
and I
is.
failed.
What it is. I'm trying to emulate what I did in the last setup for the sun, but I didn't do anything. All I
No.
used was the
Yeah,
default
yeah.
sun. So I'm trying to match the default sun, which I already have a default sun. So what I could do is open up another project and show you the default sun, and then do it from there. So let's just do that.
When you
go
say the
new.
default sun, it gives the impression the default according to the mainstream science, which means the sun is going around.
Bro,
Okay,
he just
see
needs
this?
to model what's illuminated. Remember, he doesn't
See
need
this
to
here?
model where the sun is, just
This
what
here,
it
this is the
illuminates.
default. This is the default sun. So all I'm doing is going into my web data here, and I'm asking to give me this. And then what I do is I type in a location, which in this case is, let's do Hawaii because that's what we were doing. And let's bring in the view a little bit higher up.
What's the purpose of the dome thing? What is that supposed to show?
Okay, so there's Hawaii there again. You just go a little closer to it. Section it off. Should just do it. I don't know why. There we go. Then
God,
add
who's
the-
breathing into their mic? Like,
Nope, that
added
might have been
the
me.
elevation data.
That dome's supposed to be the Bob and Dale's dome of observation.
There's elevation data there. Let's just exaggerate some of it. Too much. And then all I did was for the sun, was I started here. I took the keyframe. I think it was rotation. Let's see where you're at here.
So what's the end goal in all this?
Showing you elevation data, showing you flat plains, showing you that over a section of 3 miles, there is no dip, drop, curvature, no 8 inch per mile square. Showing you that the observers, I have many Blender things.
Why
I'm gonna
why
release
would
that
you
I've done.
expect there to be curvature
Oh.
in elevation data?
So what I'm okay, listen, Brenda. What I'm trying to get convey to you is for a 6-foot observer, there's an apparent junction of the sky and ground. All this stuff is showing you over a
Yeah.
section of well over 3 miles, well over 8 miles, that there is no dip drop. All you have is a
Right.
measurement of a horizontal surface with elevation data.
Because it shows. Yeah.
Including-
Why would you
listen,
expect elevation to
listen,
show curvature?
Including that the observer's perspective, the apparent junction of the sky and ground, is based on an optical thing and not a physical curve thing.
Why would you expect
The reason
elevation to
why
show
I'm using this-
curvature?
the reason why because it's against the horizontal means. Okay,
No,
to
but
get elevation,
elevation
you need a
is just
horizontal means.
elevation
To
is
get-
just
to
equidistant
get
from the center of the
horizontal-
Earth.
To get vertical, you need a horizontal. Bottom line. Okay, this is what you have to realize is being
Right, right.
presented to you.
Right,
Presenting
so-
is horizontal information with vertical data. This is what's being presented to you. This is how
Yeah.
elevation works. Elevation
No,
doesn't
it's not
work
how
off of curvature.
elevation works. It's
Elevation
not.
works off of a horizontal measurement. Yes, that's
No,
how it works.
elevation is
So-
equidistant from the center of the Earth or the center of the
Good
GIS.
luck with that, Brenda. The way I
Yes.
measure it is off a horizontal surface, my friend, not with your.
Yeah, it's projected. It's projected. But
What you've just
why
done is
would
you've just used your fake wizardry? The bottom line is it's measured from a horizontal means. Bottom line.
yes, but
That's how
elevation isn't
is
going to show you
quantified.
curvature.
Bottom
Elevation
line.
is never
So
going to show
when
you
I
curvature.
Exactly, Brenda. So what I do is I show you this example of an observer
That's
with
the
the
problem.
elevation and horizontal data, because that's what I'm being presented is horizontal and elevation data. I'm showing that a 6-foot observer. I'm
Yeah.
showing you at a 6-foot observer, and that location between the elevation and the horizontal data has an
Right.
apparent junction of the sky and ground.
Right.
And
So-
that's due to optics, Brenda.
Right. So sea
There is
level.
No,
So sea
there
level
is
here.
no curvature.
Right.
The elevation and
Right, of
horizontal
course not.
data substantiates a flat plane, and
No,
then
it
there's the
doesn't.
optic understanding of the apparent junction of the sky and
So-
ground.
so here you have-
that over.
You just said there's no curvature.
Brenda, you say
So
no
here-
to everything.
So here you have the island of Hawaii, and at sea level, right there on the coastline, the elevation is 0. And if we move over to California, at the shore, the sea level is 0. There's going to be no curvature.
Exactly.
In your model, there needs to be a curve there.
No. No.
Yeah.
You
Yeah.
plot 100 points on the ocean, all at sea level 0, and they're going to plot a flat line.
Hang on, why are we helping Brenda? Why are we trying to tell her what her model is? It's like-
Yeah, well,
Sea
hold on.
level-
First,
Sea
Yes,
level.
you're right,
Brenda
Brenda,
make a-
there is no curve.
Brenda
The
made a huge mistake when he said he was measuring to the center of the Earth. Altitude is not measured from the center of the Earth to the sky.
We're
It's
talking
measured
about
from
sea
the
level.
ground.
We're talking about sea level.
Sea level. Okay, sea level is not determined for. You don't go to the center of the Earth and then dig up to determine where sea level is. So the center of the Earth
Actually,
has
you do.
absolutely
It's-
zero. It has
so
zero
the
to
point
do
is-
with where the measurements are made.
So that's not true. So sea level,
Oh,
sea
come
level
on.
on the
Come on.
coast, sea level on the coast, sea level on the coast of Hawaii, the elevation is 0. On
Okay,
the
but
coast,
how do you know the distance from the Hawaii's coastline to the center of the Earth? How did you measure that distance?
we know the circumference of the Earth. You can
I
calculate
don't want
that.
to tell you. Don't tell me what you know. Don't
Yeah,
tell me
we
what
do.
you know.
What do you
You're
mean? Don't
saying-
tell you
you're
what you
saying-
know. We know. That's
okay,
what we
so
know.
This is what I want to know. Here's the thing. You're saying you're measuring these elevations, right? Like now, Flat Earth Data is saying he has his elevation data points from the ground, right, to where the elevation is, and he's tracked them and measured them, and there's no curve. Now you're saying, well, that's because you're doing it wrong. It's not from the ground. It's from the center of the Earth. So can you show us how you measured to the center of the
Well,
Earth? Or are you just going
technically-
to say, oh, we did some math?
Technically, it's not quite the center of the Earth. It's from the
Oh,
GIS.
technically.
The GIS
Well, show
sphere.
us that.
Oh, a little bit off.
It's
but-
from the
It's left field, not center field.
No, technically it's a geoid. It's the geoid of the Earth, but close
Okay,
enough.
well, show us that then, Brenda.
So that's calculated from data.
So you didn't measure it, you calculated it.
That's what a measurement is a calculation.
No, a measurement is a measurement. A calculation is a calculation. That's why they're called
No,
different
no.
things.
They're the same thing.
Otherwise, a calculation would be called
Yeah,
they're not.
yeah,
A
it
calculation
is.
isn't a
Yeah, it is.
measurement.
A calculation
I'll
and a
tell you how it's
measurement are
wrong.
the
No,
same thing.
it's a calculation.
Brenda, can you calculate
Wow.
the weight? Can you calculate the weight of a dragon that's made out of gold, that's 5 feet tall and 16 feet wide? If I gave you all the other dimensions, of course, you
yes,
can calculate
yes.
the weight of but it doesn't make him real. So now, when
I
you
didn't say it
calculate a
was.
distance, okay, but when you calculate a distance, that doesn't make the distance real. A measurement makes
if
the distance real.
if the measurements are based on
If
real data,
if the measurement is a measurement, it's
if the
real.
measurements are
If it's
based
a
on real
calculation-
Based
data,
on reality, but yours aren't.
they are
'Cause we're
based on
showing
reality.
you reality on the screen now.
No, they are
Yeah,
based
Flat
on
Earth data has-
reality.
No,
Flat Earth data
that's
has
reality
actual
on the
measurements.
screen.
That's not reality.
Those are actual measurements.
Oh, that is the better description. You're not even showing us anything at all. He's showing you how elevation data is shown on a flat plane, depending on how high things are there further up you are just
Okay,
saying we calculated, but
Let's
you're
try
not.
something. Let's try something, Paige. Let's try something, Paige. What is the elevation of the beach in Hawaii?
A sea level beach. Sea level.
Yeah. What is that elevation?
Well, you got to define what elevation is first. Is elevation from the center of the Earth to an imaginary point in the sky, or is it from the ground I can touch to a physical measurement in the air that I can get to?
I asked Paige.
Yeah, okay, but yeah, this is a community thing. So before we get into some quagmire of elevation, why don't you clearly define what elevation is? Are we measuring from the ground to the spot in the sky, or are we measuring from the center of the Earth to the sky?
It's defined as sea level, so it's 0.
I don't care how it's defined.
Yeah,
Where does the measurement go from? Where's
I
the
need to know,
starting point? The
am I
ground?
measuring from the middle?
Elevation and altitude are two different things.
Okay, now okay, but I don't. All I care about is the measurement from point A to point B that fits Flat Earth Data's map and his thing. So
I mean, if you can show me that they've measured from the middle of the Earth to the sea level and then to the top of a mountain, great. Show me if they've done that.
Yeah, they've done that.
They've measured. They've actually physically measured it.
No, they've
Because
calculated
they physically measured from the ground. Yeah,
No.
but I'm saying. I'm
way.
saying I can physically go and measure from the ground to the top of a mountain.
Paige, if you hand me a basketball, I can measure the radius of that basketball without popping it.
So?
No, you would have
Right?
to physically measure this. You would have to physically measure the circumference first.
Yes, and we've done that for the
Okay,
Earth.
okay. No, you have not.
Yes, we
This
have.
is what I'm
Yes,
telling
we
you.
have.
When did you? No,
It's
okay,
been done
okay.
many
Well, show us.
times.
It's
These
been
are
measured or
surveys.
calculated?
These are surveys.
Calculated or
These
measured?
are surveys. They're measured.
Okay, here. Let me.
These are
Yeah, and the surveyors I know say they measure everything on a flat plane. They take measurements, then 50 meters or whatever. Then they put a little peg. Then they go another 50 meters. Check back on the last two. Then go ahead another one. Put another peg. So they're all just little square flat areas, and then you just put them all together.
That's land surveying, not geodetic surveying.
Okay, here.
Exactly, and the land surveyors are surveying the actual land.
You know,
And that's
geodetic
what we're
surveyors
talking about.
measure
Reality.
No, geodetic surveyors measure
Do
the
math.
Can I show something as well?
No,
regarding
they
this? I have-
geodetic servers. They measure imaginary drop through the visual.
No, it's not
They,
imaginary.
they
it's
do
real.
math. They don't do actual measurements. It's the planar surveyors that do the actual.
Math corresponds to reality. So yes.
No, math is I heard this great thing. Math is a man-invented math. People like to think that there's a new math. Hang on. There's a new math discovery out there waiting to be discovered, but it's not.
Yes,
it's
yes, there
invented
are.
in the man's own head. So, okay, so go
Math-
lift the rock until you find a new math formula.
it is.
Can
It
you at
is.
least let somebody finish a sentence? Like, I can hardly hear what he's saying because every 2 seconds you jump in.
That's really rich.
Can't
coming
handle
from
the
you.
wrong thing.
That's really rich coming from you, Paige. You interrupt everybody all the time. You completely disrespect everybody.
Just like
Sure, Brendan.
You disrespect everybody, Paige.
Right.
Oh, I think she's
You're one of the rudest. You're one of the rudest. You're one of the rudest people here. You're extremely
I've
rude
never
and
sat
disrespectful.
screaming "fuck you, fuck off" for 45 minutes at anybody.
You're
I've
extremely
never
rude.
done that.
You're extremely.
I've
rude.
never done that.
Hey, Brenda, can you do me a favor? I have an observation for you to do, and it's just requiring you to do a horizontal and elevation data. It's a real easy observation to do. It's I don't know if you can see Blender there. I did it's over a distance of 110 miles.
We don't see Blender. We see your web page.
Yeah, good. Well, I'm showing you this example here. So what I've done is I've taken the dimensions of 110 miles. I've scaled it down to 1/100,000 scale, just like a miniature model would. Just like we're doing in these models you actually see in Blender, but I decided to do one with just paper and, math calculation, right? So the above picture shows me where I've calculated in centimeters the height of all the objects and reduced it to 1/100,000 scale. If you look at this here, this is something that's duplicable, repeatable, and observable. And what's really awesome about it is when you do it, you realize that you don't actually have to add in any curvature. And of course, over 110 miles, there's about 8,000 of a foot drop based on the geometric drop of your your ball. And the best part is it's not over water, right? So there's no not much refraction, right? So if you take the mathematics of your ball and scale it to 1/100,000 scale, between the disc, you'd get what, a 270-foot radius. If we scaled the 3,959 mile ball down to 1/100,000 scale, you get about a 260-foot radius. And this particular section is only 6 feet. So from position A to position B along that 6 feet, you're going to have about a 2.5. You're going to have about a 2 point.
Where's A and B?
Position A. So sorry, let me rephrase
I don't see
that.
any letters.
So,
I don't see any letters.
Yeah. Okay. So from the observer's view to the end of the observer's view, which is in this particular case is Mount Jefferson, would be observer B. Let's say point B would be the end. Point A is the beginning. Point B would be the end, right? And at the end of the observation is Mount Jefferson. Well, you can see in this observation here, it's poorly displayed because of the small imaging here. But if you go to that site and try the images out and try it yourself and do a panoramic, because the key word here is the panoramic.
Yeah, the bottom picture is a panoramic.
Yeah, and so is the top one. The top one's a panoramic too. I emulated reality. So what I did is I took the height of the mountains and the distance, just the horizontal information and the elevation information, and I reduced to 1/100,000 scale. I've used this model and I've baited, I don't know, hundreds of anti-humanitarian people looking for truth. In this particular example, I've gotten Christians, pastors, teachers, scientists, all this stuff with the math. Now, what I ask you here is along the 6-foot radius, how much drop should be based on the geometrical part of your model? Do you know?
Well, if you're showing if you're showing elevation, then you wouldn't expect any curvature since you have an elevation map.
What I'm doing though is I'm showing you 2 points in reality. I'm scaling it down and it's matching observable reality. I'm not accounting for any curve. Over that 110 miles, there should be over 8,000 feet drop. There isn't. I'm not calculating for it. I'm not even negotiating it. And the best part about it is, Brenda, is when I go into Blender and I capsulate over top topography-wise of the same area, guess what it matches again? So not only from the vertical bird's eye view does it match my observation, but it's clearly repeatable, demonstratable, and it's showing you that there's no physical geometrical radius of 3,959 miles. You're welcome.
Yeah, I don't see how any of this shows that since you have an elevation map and you wouldn't expect to see curvature in an elevation map.
So, Brenda, if you
and
take
you also
reality,
have an equidistant, you
going
also
to
have a
scale
panorama
reality
there,
down,
which
you're
is
going to either
which
do it
is
in two
stretching.
facets. You're going to use plain Euclidean or you're going to use non-Euclidean. And in your case, your model has non-Euclidean geometry. Okay, it's ball mathematics. That means you're going to have to account for some dip, drop, something of a geometrical nature. In this particular example, all I do
you're
is
just
Euclidean.
talking words. You're just talking words.
Yeah. All I've done is done Euclidean.
I don't think you even know what these words. I don't think you
vertical,
even know what these words mean.
Or horizontal and vertical, proving no dip, no drop. Now I ask you, this is here for anybody.
Damn it!
To me, this
always
proves
happen?
there's no 3,959 mile radius.
How does it prove that? Could you explain it to me? How it proves that?
Brenda, a distance between 110 miles between observation A and observation B, between that tangent point, how much geometrical drop is on your ball?
It doesn't matter if you're plotting elevation.
Yeah, it's elevation. It's not curve.
So elevation has to do with your 3,959 mile radius?
Elevation is the
Tell me how
distance.
elevation. Tell me how elevation has to do with your radius. It doesn't. Elevation
Yes, it
is just
does.
something.
Yes, it
How does
does.
it? How does it?
Elevation is the distance above some reference point, typically sea level. So elevation is
So
typically.
my elevation will change the radius size of Earth. Is that what you're telling me?
So no,
Exactly.
elevation
So why
is
does
typically.
elevation- why does elevation?
Excuse me. Elevation is the distance above a given reference point, typically above sea level. So sea level is usually 0, right?
So
and
we
so
agreed. Elevation doesn't change the radius. So I'm asking you, along the tangent line, what is the geometrical drop based on your radius? Because that's all I need.
there would be no
In this
geometrical
example-
drop. There would be no geometrical drop because
So
the elevation.
how do we measure curvature then?
Differently
Along that tangent line, how are we gonna
not
measure the
using
drop?
elevation data because elevation data doesn't show curvature. So
I'm
the
just doing a
elevation.
model with
Why not?
Yeah,
two-
the
Because
elevation.
there is no curvature.
So
I'm
the
using-
elevation, the elevation
using
of the beach,
here.
the elevation of the beach on on the Hawaii Islands is 0, and the elevation of the beach on the shores of California is 0, even though there's a huge amount of curvature between them. The elevation map, the elevation map is going to show 0 difference between the beach in Hawaii and the beach in California.
Has nothing to do with the radius. Elevation has nothing to do with the radius. You just agreed that the elevation has to do with
the distance above a reference point, and the reference point is sea level.
So listen, what is your radius? It's 3,959
3959 typically.
Wonderful.
Yes, 3959.
Over 110 miles along a tangent line. If we were to put a straight tangent line 110 miles away, from the beginning and the end of that tangent line, what would be the geometric drop of your ball Earth over 110 miles?
Yeah, I don't know. So if I have
8,000, it's almost 8,100 feet. Okay, basically that's the drop. Now listen, if I was to scale your Earth down because I was thinking it was a ball, I would negate that curvature formula, or would I use that formula, or would I just forget about that formula? The drop, when I scale things down, am I going to add the curve drop in or not?
Drop is.
And it doesn't matter.
I love these answers. They don't matter. You don't know what you big words. You guys are just so destroyed. It's awesome. Love it.
No. You just don't understand what elevation means. It means your distance above
he's
a
insisting
reference.
on shifting the conversation back to elevation rather than addressing the point you're currently making.
Because he doesn't understand the point.
He just agreed elevation has nothing to do with radius.
Flat Earth data. Flat Earth data.
Listen, if you're going to compress your radius of your ball, you're going to use a tangent line to adjust the curvature to make sure that you're scaling it to the right amount. So if we were to scale the
Flat Earth data, I would like to talk for a
scale
second.
down, listen, if we were going to scale down the Earth at 3,959 miles to 1/100,000th scale, what would be the circumference, radius, and what would be the drop over 6 feet? These are very easy, reasonable questions to ask because it's based on the presupposition of your model.
Because you don't understand this. So let me speak for a minute.
Answer,
you've had a lot of time. I would like a little bit of time. So if I have a boat in the water off the shore of California, and I have another boat in the water off the shore of Japan, right? There's a huge amount of curvature between them, but they're at the same elevation. They would be at 0 elevation. And if I have an elevation map, that map will show both of those boats at 0.
So, Brenda, what you're doing is you're ignoring a blatant evidence of data that's horizontal and vertical.
No.
Yes, you are. And then you're like, well, of course there's not going to be curvature in the Earth.
Because you have, and you're making this based on elevation.
The data shows you that it's a horizontal and it's an elevated plane.
If you're using elevation,
between 2 points of equal elevation is horizontal, my friend. This is classified, diagnosed, dissected, and applied in every building construction possible.
So
2 equal points of elevation are
That's
horizontal. This is an axiom of Euclidean principle. The point is, sir, this is how you measure your drop. So if we were going to reduce your ball to 1/100,000th scale, please tell me how much drop would there be over 6 feet?
So the
and if
boat,
you can do this, if you can break it down, and
the
you
boat
look at
over California
reality,
is at 0 elevation, and the boat by Japan is at 0 elevation, and the boat in the Indian Ocean is at 0 elevation, and the boat in the Atlantic Ocean is at 0 elevation. The boat in the Arctic Sea is at 0 elevation.
So
you
why
are
do you put them
a
over a
fucking
curve?
moron. You are a fucking clown.
Elevation.
Did you hear what he just said? Everybody listening, all he said was,
Isn't that a flat plane?
The boats on the ocean are at 0 elevation, you fucking moron.
Of
course.
Oh, somebody's triggered. Somebody's being very rude and very nasty.
Zero elevation. What would graphing zero elevation look like? What would it become if you graph that continuously?
You get an elevation map.
What would you get? What would
elevation
it look like?
map.
Yeah, and what would that look like? What would that map
That would look like a flat.
Right the hand.
It would look like a
that
what?
would look like
What would it
a
look
flat
Brenda?
plane with elevation data on it.
It would look like a flat plane
Yes.
that said 0 across the board. Okay.
Yes.
Yes.
This represents reality. They then take that and wrap it around a ball and go, no, this is reality. Well, hang on, you don't have a that matches that. We do. You don't.
Yeah.
Yeah,
So where does
but
this
you
ball
did
come
that.
from in this elevation? So this is the point Flat Earth data was trying to make, that the elevation data is a flat plane. So where do you get a ball from it?
Yeah, if
The
you look at
Indian Ocean is at 0 sea level. Hawaii's at 0 sea level.
Yes, yes, it is. The
Yeah,
sea
there
level.
you go. How did I know that's what
the
it is?
beaches?
There we go.
The beaches.
Oh,
The
yeah.
beaches at Normandy are at sea level, at 0 elevation.
Yeah, so why do you then
Yes,
wrap
yes.
them around a ball?
Because
Why would you do that?
Because that's the true shape of the Earth.
No, we've got photos showing that elevation
No, you
data
don't.
on a flat plane. He just showed
No, you
it.
don't. No, you don't.
Oh my god.
oh my God,
Those aren't
Brian.
photographs. Those aren't photographs. That's Google Earth.
He just showed a photo before with a scaled model.
That's
Are
Google
you
Earth.
serious right now? No. The photo, the panoramic picture of reality, he did a scaled model of.
That wasn't reality. That was a panorama with stretching in it. You could see the clouds stretching in that image.
And what does cloud stretching have to do with
It
curvature?
means that the photograph was distorted.
Oh, Brenda.
That's what it
Really?
You don't
means.
understand how
That's what a
panoramic
photo.
works
He has
then,
That's
right?
what a
measurements.
panoramic
These are
is.
data points.
What's that got to do with the floor?
It's a
You
rectilinear.
should still be able to see curve.
It's a rectilinear panoramic
You know what's funny? I
image.
did
You
with
don't
that
know what
photograph.
this
As I
is.
reached out, if you go to USMGS website, I reached out to the guy who took the photograph. Not that one, but he took another one. If you go to Ranty, can you do? I don't know if you want to indulge me, but if you go to USGS, I think USGS website there, they'll show you this shot. Go look at it. It's fucking hilarious. They purposely put it together as a panoramic, but in a ball format. It's priceless. It even shows you all the stitching and everything.
Really?
Making it as a ball from the height of Mount St. Helens. I reached out to him as I sent him an email. I was like, "Hey, dude, that's a freaking amazing photograph. It's like you were like 90,000 feet in the air. How did you get such curvature?" It was fucking. I haven't gotten a reply back from him yet, but it'd be interesting to see. I'm trying to bait them to come in to get something, but I don't know, man. Maybe they're too clever. Maybe they just know it, and when they're asked a question, they're like,
"Yeah,
you
you're
know,
much too clever. You're much too clever for them. I'm certain of that."
Yeah. So
you're
way
a genius.
More
You're
more
a genius.
clever than
You're a
you.
genius.
The ad homs coming out and the nastiness
That's not
and
an ad
the swear
hom.
words. It's
I'm
the
calling-
only
I'm
person
I said
without
he's
being
clever.
nasty to anyone else.
I said he's
I'm going to add
clever.
him right now. If you think Brenda's the clever ones that come in here and talk to us, then you're sadly
They're not
mistaken.
disturbed.
Yeah, you're not going to get a good one.
No, they're the only ones left right there. It's the only ones crazy enough to still believe this shit. Like, NASA showed us a ball. Therefore, everything you're showing us on a flat plane that matches reality can't possibly be true because NASA told me it was a ball.
I'm going to try to find you that USGS thing, and maybe we all can send him an email and ask him how high was it when he took the picture.
They're constantly asking us to model the flat Earth, model reality. You just showed that. You showed a scale model on a flat plane.
Yes,
it
I
was.
did, Brenda. And not only that,
it was
I showed you how the radius of 3,959 miles does.
I mean, if you want to ignore that, Brenda, that's your choice. You're your own person. That's fine. But everyone here and everyone in the audience can see that was a scale model of the picture. That's just all there is to it.
Well, hang on. The referee's checking the replay. Nope. Yep. Brenda, you're wrong. The ruling on the field stands. Brenda, you're completely incorrect.
Well, that's it, Brenda. Earth is flat.
Well, at least when Brenda comes in, at least we get her to be honest at times, even if she doesn't realise what she's saying.
I'm always honest.
Well, even if she doesn't know she's being honest.
I've never lied. I've never lied.
Yeah, so the data shows it's flat. Yeah, we all agree on something.
Yep, we agree on that. Yep, you weren't lying. Everything is at 0 elevation, no curvature.
Well, if you want to think that Google Earth is a flat Earth model, have at it.
Yeah,
Can I ask
we
you,
will.
listen,
It
Brenda,
is.
how are the images gathered by Google, just out of curiosity? How were they gathered? Because it's actually lots of data, but how is it initially gathered? Can you tell me, like?
I don't know, but I would assume it's from satellite images. I would
So
assume.
if I told, okay, so if they're from satellite images, how far away are these satellite images, Brenda?
I have no idea. I have no idea.
Okay, so 8-bit sensor with a 50 mil lens, 21 mil lens, 10 mil lens, 18.
I have no idea.
Point is,
I don't
these
know.
They're made with satellites. First of all, figure out how far a lens can see based on the bit rate, based on the focal length size, and based on the field view. So a field of view, when you're taking land photography, field of view, you can only bet a certain height based on the sensor, or else you don't get fucking detailed
They're
data.
not taken from the Earth. They're not taken from the Earth,
They're
dude.
100% taken from elevated, maybe 60, 70,000 feet.
No,
tops.
they're taken from satellites.
Yeah, sure, 60, 70,000 feet tops. The point is
Oh,
that
I don't know.
they're
I have no
elevated
idea
over a
how
position
high
of
they
Earth.
are.
They're elevated over a position of Earth where they can get the proper detail.
Sure,
okay?
and then they stitch
Too
them.
far-
And then they stitch
too
them
far-
together.
Too
Then
far,
they,
too far
they
you got diffraction. Too far, you got diffraction, right? Infrared has a little bit longer of a wavelength. You can go a little farther out. But even using infrared and the 16 different types of sensors they use, they have to compile the data together. And they use it for land surveying, like minerals, jewels, content. That's used all this stuff, sound and infrared. Boom, boom, there. But this is only limited to certain height distance. Okay, and I urge you to present any information scientifically that shows the sensor ability, the size of the output magnitude, and show me that it's 20,000 miles up with a sensor to get that kind of topography. It's impossible. There's no technology on the world that can do 20 miles up to shoot a field of view with that much data.
You can't
infrared is only infrared's only good for a certain distance.
Could you just stop rumpusing?
And optics are only good for a certain distance.
Could you stop rumpusing? Could you stop rumpusing, please?
The fact is I just presented to you topography shot with this particular equipment that is unbiased. Okay, because it's pointed downward and it's filling a field of view, a horizontal field of view, because it needs to measure elevation data.
Could you stop?
Could
you just take a breath? Could you just take a breath?
You have to have a horizontal position to measure a vertical distance.
Just take a breath. Just take a breath.
Don't tell me what to do, bud. At the end of the day, you don't even know how satellites shoot the images. You don't know the software. You don't know the tech.
I don't have to know. Why should I have to know?
You assume it because, Brenda, I just offered you a practical.
You don't have to know, but if you want to know the truth, then you should
I
look.
offered you a practical demonstration that you can either do two choices. You could either use Euclidean geometry or non-Euclidean.
Yeah,
to
I have
do
no
the
idea
scale
what
model.
you're,
You can do it.
How that
you can do it.
So
you can
I
do
don't-
it, bud. You can
so
do it. I know
stop
you
t-
can.
stop
Number
rumpusing.
Number two.
You're just
you
constant
can, number two, you
rumpusing.
can also study how cameras are taking topography of Earth and how the data is compiled. Look at a problem they have. It's called block grid correction, and it has to do with drone technology taking topography of Earth. The problem is that they're still thinking Earth's a fucking ball while they're doing this stuff.
No,
and
we
trying
know
to
that for a
correct it
fact.
up.
So I'm sure there's
It's
all
not.
kinds of.
Listen,
I'm
if
sure.
it is- listen,
just
if
a
it
minute.
is even
Just a
close to
minute.
being a
I'm
ball,
sure
it's
there are
way
all
bigger.
kinds of
Listen,
technical
it's way
data
bigger
and
than we've
all
ever been
kinds of
told,
details
because there is
involved in
no
taking
curvature.
photographs of the Earth. I'm sure it's
Brenda,
very technical and very
here's-
detailed, and
me
lots
ask you a
and lots
question.
of smart. I'm talking.
You're smart,
I'm
you're a smart
talking.
person, right? You
I'm
consider yourself
talking.
smart.
I'm
Let
talking.
me ask you a question. Yeah,
I'm
gonna get you
talking.
to talk about
No.
something relevant
How about
here.
you shut
If a
up
camera
and let
is
somebody
above
else
you-
talk?
Listen, if
How
somebody's
about you
above
be
you-
quiet? I'm not triggered.
Brenda,
I just want
Oh,
to
yes,
be
you
able to
are.
have.
You're
I'm not
showing it
triggered.
very well.
Let me ask you a
I
question,
just
Brenda.
want to
Brenda,
have a
let me ask you a
word.
question, please.
No, I
Before you
want to
continue
have a
your
word.
nonsense, I want to ask you a
No,
question.
no, I won't
She's got
answer
her
it.
victim card out.
I
Everyone
just
has to be
want to-
silent. She's waving it.
I just
above
want
the
to.
ground.
He's been talking for a long
If the
time.
camera
I
is
would like to
above
get
the
a
ground,
word
I'm
in
not gonna let
here.
it go to answer the question,
I would
because
like
it
to
just-
get a
it would
word
just
in,
give insight.
please.
The
Could I get a
audience will
word
get an
in?
insight to what you know. If
So
a
could
camera
I
is
get
above
into-
the ground, If the camera is above the ground, focus directly down.
So could I get a word in here, please? I mean,
Brenda,
you've been going
answer
for
the
half an
question.
hour like
He's
this.
asking you a
Brenda,
question and you won't let him finish the question.
I don't care. I'm not listening to
If the
him.
camera is pointed
I just want to
downward-
get a word in.
Then why are you here if
I
you're not
just
going to
wanna
listen?
get
If
in.
all you want to do is talk.
I just
yeah,
want
all
to-
you want to do
why
is
don't
come
you
here and
let me
spew
talk?
what you want to
I
say.
just want to have a word.
But you're not
Just-
listening to
Just let
anybody.
me have a word. Just let me
Brenda,
talk.
when you're ready to,
So-
when you're
so
ready to let me know.
You need
I
to
would
listen
like to
before you
talk.
can
Want me to
talk.
answer
So
this question?
I just want to get a word in. I just
Yeah,
want to
you
get
can,
a word
you can
in.
get a word in when you're asked a
No,
question.
no, I'm not going to.
Yes,
I'm
but
not going to
after you
dance it.
don't know satellite.
I
question.
just want to get a word
You
in.
don't know satellite. You don't know. You don't have to know. It's
Oh
I
my
just
God,
would
who
like to
is
get
that?
a word in. That's not me.
I just
Killing
let-
my
That's you.
ears,
let's let
whoever that
Brenda-
is.
I just
let
want to
Brenda
get a
get it
word
out.
in. I just want to
Let- let-
talk. I just want to have a
Yeah,
back
she
and
won't
forth.
stop when she's triggered. She'll just keep saying, I want to get
I'm
a word in,
not
I want to get a word in, 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 I want to get a word in.
All right. So what is?
I just
what
want to
is it,
get a
Brenda? What do you
word
wanna
in.
tell
I
us?
just
I just want to get a word in,
Okay.
see?
Go ahead. Go ahead.
She will not stop.
Jesus fucking Christ, you people are fucking children.
Oh, wow. So triggered.
Come on, Brenda. You have the floor. Use the floor.
Right. So the central problem is he doesn't understand what elevation is. He doesn't comprehend the idea that when you have an elevation map, it's going to give you the mean height above a given reference point, which in this case is the ocean, the sea level. And it's going to be...
Which is flat.
It's right.
No,
You
that's
know that.
it's
You are
not
saying
flat.
that again. Yes, you
Holy
are right.
shit.
Brenda.
Holy
You are right.
shit.
What do you want? Yes, sea level, yes. Just the height be above the sea level. And what do you mean? Of course, there is no curvature. I don't understand what you mean.
So Brenda, if a camera is pointed towards, if you had a camera in your hands and you're pointing the lens at the ground and it was perfectly at 90 degrees towards the ground, that field of view of that camera would pick up a field width of the floor. With that field width between one edge of the frame to the other edge of the frame in the photograph would represent a horizontal line. Would you agree with that?
Unbelievable.
I was going to say, if you didn't hear her talking, then something either.
Is
the point
Brenda
is-
talking or I can't hear anything?
Yeah, I might have to join and rejoin, or maybe just maybe
Okay.
the CPU has to reboot.
Hey, Ranty, I can come back with
Talking.
another demonstration in Blender regarding optics, showing you that with a 2-degree slope, an object will appear to move downward. The sun will appear to move downward past that optical limitation. Of course, it's, applying in that 2-degree slope, right?
Works.
I don't know if that matters.
Flat Earth, though.
Well, yeah, I mean, if it works, and you've got something that you want to present, absolutely, I'll show anything you got.
Okay, I got to come back because I got to switch platforms. I'm on a PC platform. I got to go back to Mac. I'll be right back.
All right. So I don't know what happened in the past 7 or 8 minutes or something, because I went downstairs to make myself a hot chocolate, came back and the chat's erupted. What went on?
Oh, that's a good idea.
Brenda got very triggered.
Chocolate.
Do you use milk or water to make the hot
showed
chocolate?
up,
Ryan?
I use milk.
Oh, there you go. You can't make it any other way.
So were you all being naughty whilst I was gone? Shouting.
We were
No,
being
no, I
naughty,
think
no.
I thought it went pretty good. I thought it was pretty civil. There was no real name calling.
Okay.
But yeah, no, we have a
If
pretty
I plead
good
the
solid
fifth, do you
flat.
understand what that means?
Huh?
I said if I plead the fifth, do you understand what that means? I don't know if you guys have that over there.
Is that like you are abstaining from any kind of comment?
No
I don't have
comment.
to speak and incriminate
Yeah.
myself, basically.
I
Yeah,
don't plead.
okay.
I don't plead a fifth. I plead 1.5 liters.
We did get Brenda to admit that it's flat. The data from the elevation would create a flat graph. If you mapped it out or plotted it on a graph, it would be flat. So
Yeah, of course.
that was a win.
Yeah,
Oh,
that's,
that's,
not,
that's
a,
pretty cool.
that's not a win. That's not
So
a win
I
for
actually
you.
missed Brenda admitting it was flat. Right? Okay,
That's not a win for you.
So using a field of math, it looks flat, but she won't accept
Certainly
math.
ain't a win for you.
Well, no, you just map it out using a flat base. Does it mean that the Earth itself is flat?
Yeah, but then he put a scale model showing
but then
on
it
a flat
matched, yeah.
plane, and it matches reality. So then
matching
it is.
The matching
That's
is your problem.
what's.
No, it doesn't because
Do the
you can,
same
you
thing,
can
Nick. Do the
measure
same thing on a with
dip of
curve.
objects.
Show us the curve. Yeah, take that elevation data and do what that guy did. Do a little scale model and show us where the curve is.
It's been done. Objects
No.
the same elevation over distance will drop.
Perspective.
Perspective doesn't make objects at the same elevation drop.
Yeah, see, this is
Yes,
why they
it
don't
does. The
measure.
further away.
Okay, so if I look down a hallway, you're telling me that if a line were painted at eye level down the length of that wall, that eventually that line is going to start to dip. That's not what we see.
Yes.
We see it go straight out into the distance.
Here's the
No,
problem.
you don't. Everything go. Oh my god.
No. Perspective makes things above your eye level come
Okay.
down, and things below your eye level come up. But if something is at your eye level, it remains there. Because you can't have it both ways, where it drops but also goes up. Does that make
Here's
sense?
your problem.
No,
Here's your
I don't
problem.
have a problem.
So-
I'm right.
Okay, well,
You're
then
wrong.
let me speak.
Well,
Then let
and,
me
and
speak.
you're.
So when
Oh my god.
Okay, stop talking.
So how fast does it come
So
up to
the idea-
the shoreline? If you know how fast does the things underneath you come up to you from underneath, and how fast does it go from above?
Faster from the floor.
No, slower from the floor.
Slower from the floor. Faster from the sky. It's one way. It's one or the other, not the same.
So it's an optical thing. It just tricks your eyeball to see curvature because the top is going much faster. A plane.
Hey, Ranty, you can
No.
you can unmute Crow Axie.
Oh, has he finally
Why,
muted
but I-
himself? Right. Okay. Because we're getting echoes whenever we. There you go. Can you hear? Oh, there we go. Right.
Hang on, let me say one thing real quick. So this is why you don't use optics to take measurements, right? Because of the dip in the angular size reduction. So when they measure something, they do all the physical measure. Hang on, man. Hang on. You'll have your chance.
You're
So
saying things that are just wrong.
Okay, but you gotta
Yeah,
let me do
but
it.
okay, you can say
Yeah,
things
you
that
can't
are right.
interrupt
Okay,
me.
but
Let him
come on, man,
finish,
don't
and then you
interrupt.
can say, "I don't agree with that," or "I don't agree with that." But let him finish.
Okay, keep saying things that are wrong. Go ahead.
He can. That's his prerogative. It's his turn to talk.
Yeah, I've made my entire YouTube following on saying things that are wrong. So don't worry about it. One more thing is not going to mess anything.
That's true. What is your?
Okay,
You've
so
got
then,
to
let me
interrupt
get it.
again.
So I got it. Yeah. So okay, so when they measure everything, they physically measure it. Like they'll walk it, they'll look at it. And this is where the data points for the elevation and chart comes in. Now, when you start looking, right, you've left the measurements because if we measured a foot from the ground, and just kept going, right, and then we started measuring 10 feet, we would know there's a hill, right, and then we would know there's a dip. So these things would be measured. Now, when we measure this all flat, but then you walk back over the measurements, look where we already measured, see dip from optics, and then say, well, there you go. You see that switch you did? We already have it measured flat. That's why the data reads flat. The only time you can make a ball is when you look and then put perspective and angular size reduction into a physical thing.
Nope.
Exactly.
All wrong. But you're not a flat earther, though.
Okay.
Chris.
If all you have to say is all wrong and I'm not a flat earther, I'll rest my case on that. So, great defense you put up.
Can somebody who is genuine please explain how perspective makes everything dip? Make it go
Okay,
down?
That's irrelevant. That's irrelevant to the point that they don't use perspective or optics to measure. The measurements are done
we use
physically.
optics to measure
Hang on.
all the time.
Man, come on, bro. Come on, Negatron. Come on. Be a normal person. Don't interrupt me.
Well,
So the
a
idea-
normal person
I know,
wouldn't
but
lie
a normal
about using optics.
Okay,
right?
but here's the thing. Now, why do you make now? This all comes now. This is every time I get into a conversation with anybody, it always comes down to they will interrupt me, but they have a reason.
Well, because you're just jerking people around. You're not actually.
Okay, well, that's
flirt
your.
for-
Okay, well,
you're
I
just
think
here
you're a
to be a
government
jerk.
agent. Yeah, and I think you're a government agent sent here to obfuscate the truth. And you
Okay.
do work for the government, right? They pay you. You're getting paid by the government, right?
Sure, yeah.
Yeah. Okay. And you're here. And why is flat Earth interest you so much if you know the Earth is a ball?
It's the curiosity behind.
Okay, but you've been here for like 6 months. Why the curiosity is done? Why do you keep interrupting? Yeah, but now you keep interrupting.
You
Now you just
actually
need to. The
interrupted
curiosity's
my
gone.
answer to your
So
question,
are you here?
right?
Yeah. Look at his little cadence. Do you hear his little cadence change? They teach this stuff. Why are
They
you,
teach
why
this
are
stuff.
you interrupting? Yeah, they do. You dumbass. They take class. I took the
guy's,
same stupid classes that you
he's
took
an
that you think are
expert,
working on all these people.
You look the same. So which classes did you take?
The same stupid
Which
class,
ones?
the
Tell
same
me.
stupid things they tell you. They're like,
No,
just remain
no,
calm.
which
You're
classes?
gonna
Where do I
wanna
sign
you're
up
gonna
for
wanna
these classes?
obfuscate from points. Now you also have to use a condescending tone because that makes you seem like you have an authoritarianness to you, right?
Well,
Isn't this something
I
they
might
tell
come
you?
across it kind of saying.
Yeah, bro, because you're using
That's up to you.
tactics. I know your conversation tactics. That's what you're doing. This is why you're trying to. I can attack you, the person, and I can do better than you. You could just say, no, you're wrong, you're stupid. I can show and you admit that you work for the government, right? So I have proof of all my claims about you. You just have your personal opinion. So this is why you have to do this. So when we're measuring elevation, nobody's measuring a curved surface. Nobody does
You
that.
can.
It all charts out. It all charts out flat, my man.
Right
Even
the
though I
hand.
didn't make it.
Right the hand. Negator is CIA.
There you go. Look at that. Look at that. I told you. I know because they're here. They're here to infiltrate. Even though they're so easy to fucking spot. It's like when you see a cop at a diner eating a donut. If there's
You wanna
more than
know
one
the,
donut, you know it's a cop.
The secret behind.
No,
your
you want
man
to
bun.
you want to see, bro. This is all about data. You're all about data. I know what the government's. It's all about data. You're all about gathering data. That's why you're here. You don't think you would do something better with your Friday or Saturday night? It's Saturday night. You're here on a flat Earth surfer. Oh, because you know the Earth is a ball, though, right? No, you're on a mission. What's the mission, Negator? Tell me. Come on. You can tell me the mission. What is it? What do you hear? Are you? Well, there is no mission, right? It's just to gather data, maybe to sway the conversation in a certain direction.
Is this entertaining or no?
I know.
Should we continue?
It's to not let the conversation. It's to not let the conversation get to a certain point, right?
Please keep
That's
going.
why you're. Oh, that's why you're here. You're here to make sure the conversation stays within a certain confines, right?
What happened to the conversation?
Yeah. Negator fucking infected
a
it.
troll here, so.
Yeah, the troll, yeah.
When
the
Flat
one who
Earth
won't
is-
talk about anything.
He's got a good point about it being a Saturday night and you're here, Neg. You're a young man. Like, why aren't you out?
I'm actually
You know
older
what?
than right the hand, but that's all right.
Oh, so you're not a young man?
Yeah.
You guys
I
are
can
here.
write the hands a young man.
You guys are here.
Yeah, why would
Flat Earth is here. Why is it?
Yeah, we're here because we believe this is true. You're
No,
here
you
because
don't.
you
You're not
think
one
we're crazy.
of them, though. You're just.
Well, it's
you're-
actually-
And it's not Saturday night for me. It's 9:30 Sunday morning.
Yeah, attack
When
the
Flat
character
Earth
when you
is
can't
start,
do anything else.
when Flat Earthers start accusing ballers of being shills, it shows your true paranoia and how messed up you actually are.
Yeah.
He admits
It shows
he was
how
right.
scared
He
you are.
admits it.
Well,
He admits
It
it.
shows how scared. It shows how scared you are.
Scared that we can
of
scale
everything in the
model
world.
reality and show it's on a flat plane. Yeah, that terrifies us.
Okay, so
the world's against them, right?
When you think that we're paid shills, when you think that we're
I
paid shills,
didn't
your
say you
paranoia
were paid
is
shit. I said why
11.
why on earth would young men on a Saturday night want to spend their time talking about something they think is stupid with people they think are stupid? Like, is your life that
Because they
bad
like
that
it.
you've got nothing else to do?
Because he's interested in the debate. Perhaps
Yeah,
he's
but
got
he
a
doesn't
sick mother.
talk.
Perhaps
He doesn't have the honest conversation. He stops at certain points, and you'll ask him, "Hey, what do you mean by this?" And then instead of getting an honest answer, you
Yeah,
get
you can
stalled.
tell the ones that actually
And all
want to
you
know.
do-
They will
and
tell
all
you.
you
This is what
do-
they're here for, bro. This is
and
why
all
when they're
you
not
do
here,
right
you hear
the
the
hand is talk
conversation
shit.
flow so much.
Okay, well, let's start again.
And all
guys.
you do
Let's
right to
start
hand is
again.
talk shit.
Hold
All
on,
you
yeah,
do
hold
is like to
Hold
listen to your
on.
own paranoia.
Hold on, everybody.
By the
hold
end
on,
of-
hold on. Right, so Negator. Right, so
Mhm.
what is it you do in this debate? I mean, do you do any experiments, tests, or what is it? What is it that you actually do, or do you just hang around these debates?
He calls out bullshit.
What do I do? Like, what's my purpose?
Well, no, I mean, what's your well, what's your angle in this? I mean,
Motivation.
What's it you get out of it?
I find it extremely interesting to try to weave my way through the thought processes of folks that to the outside world look irrational or appear irrational. I think there's a little bit of a challenge to it to try to figure out why they think the way they do.
And you
wait a
think
second,
just
Negator, you
telling us we're wrong and not giving any evidence on your side is doing that?
It's like, wait a sec, Paige.
Wait,
Negator,
Ranty, was
you
that a suitable response, or do you want me to keep going?
Well, no. Well, I was going to follow up basically by just saying, well, because you have been around for years, years and years and years. I mean, what makes you stay around for as long as you have? I mean, is it becoming a bit of addiction to you, or do you not see that the way that our answers have progressed recently that might offer a challenge? Does that not make you think anything about the flat Earth, or are you still adamant it's a globe? I mean, you can see that we are doing research into this, and our research grows, yours doesn't.
I absolutely think it's an addiction, and I absolutely see it as a challenge, because every time somebody brings something new up, you have to go dig in and figure out why. And I've got an uncontrollable innate need to to correct people, and I don't know why, but this is just like
because
this
you
is
think
the mountain of correction that needs to happen.
Uncontrollable. He just said uncontrollable. They have no control over their emotions, their feelings. They let their feelings and emotions control them.
Yeah,
and he just admitted that.
Yeah, like Paige is under control. Like Paige is under control.
Actually,
so I've got another question. So can you ask me? I've got a personal question to ask you. So it's a logical question. So if you're at the beach and you're sat down on your bum and you're right next to the water, and let's suppose in your head is about 3 foot above the water, right? So you've got your feet in the water, but your head's about 3 foot above it. And you're looking out to sea, and there's a 5 foot wave out there in the distance, right? Blocking your path. Do you think that 5 foot wave will stop you seeing things behind it? Or partial things behind it? Or does it need to be a 200 foot wave?
Well, before I answer that, I want to answer Paige. I think that my demeanor is extremely controlled. And as far as your question, Ranty,
you were the one that said uncontrolled, Neg, not me. You said it about yourself. I didn't say it about you. You said it about yourself.
All right. Anywho, I also think, Ranty, you're not a flat earther. I think deep inside. But to answer your question,
I agree. I agree.
So what's the answer to the question, Negator?
I think
these guys
waves.
have ESP
I think
on the
waves. Sorry, I think waves absolutely do block a lot of sight of things, as long as you can, the observer, or rather the observation line from the observer to the object intersects the wave.
Okay. And do you think that, like, something that's in your way blocking something from you in the distance, eventually all things, if at a great enough distance, as long as that blockage was above your eye, essentially almost everything could be hidden behind that. Even if it was a foot, a 1 foot higher wave than you.
I think we can mathematically determine how much that wave is going to block. I think a 1 foot wave from an observation height of lower than 1 foot will. I don't know, man. You need to give me some math so I can go work it out before I agree to something very vague. That.
Okay, so let's say a 5 foot wave. So let's say you're at 3 foot, and let's suppose there's an 8 foot wave out about 3/4 of a mile away. So not that far, but 3/4 of a mile away. There's an 8 foot wave. You're at 3 feet, so you've got 5 foot of blockage. How much obstruction would there be at, let's say, 20 miles? Should be pretty easy.
A flat or a globe Earth?
Well, there you go. See, do you think it exasperates the effect on a globe Earth?
I think exaggerates, maybe. I don't know about exasperates.
Well, it exasperates me. All right, does it exaggerate it then? Because you're looking over that wave and your eyeball's looking up, whilst at the same time your globe is bending down and away.
I'll be honest. To really give you a truthful answer, I'd need to go do some calculations as far as angular size of the wave, distance, and a few other things that right this second I just don't feel like doing. I know that other people have done it, and I could probably dig you up some stuff. I think, hasn't this come up in the past, like with you and some other folks, as far as how much line of sight waves will block?
Yeah, people, it seems that on your side of this coin, at least, on your side of the argument, don't seem to appreciate the effect that waves and shoaling and swell has. They don't seem to understand that. There's a plethora of information out there that explain the same thing, where the effects happen, how they happen. You can find the data for the regions. It's very easy to find. And yet that is totally ignored by the globe earthers. And it is a massive problem.
No, it's been answered before, Ranty. You know that.
Yeah. Here's
one. So currently we're having this discussion with B-Ball for Life, and he's doing some observations in Hawaii. And I was able to determine that about 3/4 of a mile from his observation, we had 8-foot waves. Swell, shoaling, and the wind-driven waves, 24-mile-per-hour winds, the Beaufort scale. So all those things added into it causes obstruction. But the globers don't want to acknowledge that. They just want to say that it's a perfect proof of globe, because mathematically that works, you see. But that's excluding all the other things that went into that observation.
His height was 8 feet.
His height was not 8 feet. He even came back and said his height was 5 feet. When I pulled him up on it.
He said 8 feet this morning.
Yeah, well, he said 5 feet last night. He even sent me an image with.
Did he say he was laying on his belly?
He absolutely was pretty low down. Yeah, he got those wave splashes in front of the camera. You can only get that right in front of the water. There was no way he'd have got that at 5 feet elevation. But his last claim was that he was at 5 feet.
Well, maybe one observation, but he showed something with the ground is above
But
the
if he's
water
at
with like 3 feet or something.
If he's at 5 feet and he's putting 5 feet in the mathematics, and that observation matches the globe Earth, without taking into account any of the other variables, the swell, etc., the wind-driven waves, all that stuff, suddenly he's not 5 feet above sea level. He's actually -3. So when you actually plug that in, the fact that he saw what he saw doesn't match the globe Earth, does it?
If it's 5 feet, then yes, I agree with you.
No, he's not 5 feet. He's about 3 feet taking the observation, and there's an 8-foot wave out in the foreground. So he's actually below the waves.
Now, how did you determine there was an 8-foot wave out in front of it?
Because we had the swell data on the day, we had the topography of the land that's in a direct line of sight, which gives the shoaling calculation. Severe slope is 1 in 10. In that particular region, it was 1 in 7. You've also got the wind-driven waves, which are 24 mile per hour winds. So on the Beaufort scale, that's an 8-foot wave. Of course, that's the total size of the wave. So the amplitude of that will be half. So the amplitude of the wind-driven wave would be 4 feet. The amplitude of the swell in that location would be at the very least 4 feet. So I was actually being generous. So we're talking a total of 8 feet for the two.
It's 4-foot one, so that one crosses that one out.
I'm sorry?
Well, if he's above 4 feet, then the 4-foot example is null and void because you're going to be able to see over it. So that doesn't. Yeah, you got a foot actually.
No, you've got the swell, and then you have the wind-driven waves that top that. So it's a total of 8 feet of obstruction, 3/4 of a mile away. And he's claiming his elevation was 5 feet. I've been able to show that he was more likely to be about 2 or 3 feet. Or even if we gave him 5 feet, he would be below those wave heights. But yet his observation matched an observer's height of 8 feet above actual sea level, not -3 feet.
Granty, can you hear me?
Yes, Cam.
Okay.
Are you not going to say something?
No, I was just having mic issues from last night. I think somebody server muted me or something, but
I was so anticipating something.
So yeah,
Well-
I mean, do you not think that it's kind of this information should be included in these observations? I mean, I included myself with my observations. So do you not think that it should also be included in globe Earth observations when they claim it's proof of curvature?
I guess I have one thing to say. If you watch B-Ball's video as he's panning from Barber's Point over to Waikiki, in the background of Waikiki is what's called Diamond Head. It's a volcanic crater or something. It's about 700 foot tall. They say 750. And in his pan, the buildings, he zooms in and zooms out. He does really good. And he pans back and forth so you can see Diamond Head in the background and the buildings on the shoreline or the horizon line. And those buildings, he's saying that Hilton Hotel and stuff are what 200 and something foot tall. But when you can see the mountain in the background and the buildings, and then you go to your baller scale there where you stack buildings on top of each other, the Diamond Head is much taller, indicating possible compression of the buildings.
Hey, Ranty, if you want to share my screen, go ahead. I have the blender up for you.
Sure. So that would actually confirm the research that Brandon Toys conducted this past week.
Yeah.
You'll have to show me the timestamp of that so that I can get some data from that.
Let me find it. I know.
Sure. Yeah. Is Crow watching this? He was interested in this dome.
So this is an entirely different example. What I've done here is just taken a sphere, I've turned it into glass, and then I just put it 6 feet height for the camera. And let's just go look through it. I'm going to show you something really interesting I find. What I'm going to do is I'm going to increase the refraction of the lens. And you're going to notice what happens in the background. So here's the lens. So that's the curved lens. You notice there's already a dip there already, right? Let's just go to the incident of refraction here, which is an option in Blender. It's off here, whatever that is. Come on. Where's the... here it is. So watch this. So the normal incident of refraction is around 130, I think, roughly. I'm going a little too crazy here. But I want you to notice the background when I increase the refraction. Watch the clouds. What does the clouds do? Are they appearing to go downward?
Yes, they do.
Yeah, they're appearing to go downward, aren't they? And that's all I'm doing is taking a lens, circular lens, turning it into glass. Okay, and I'm changing the thickness of it or the incident of refraction. And I'm shining a camera through it right here. Very simple to do. Go to view. Cameras, active camera, and I'm just zooming in, highlighting the sphere, and all I'm doing is changing the incident to refract. Look at the clouds. Look, are they shrinking in behind it?
Congratulations, you've discovered refraction.
Yes, and I'm showing you how it works.
No, it's
I'm showing how it works.
Shrinking the top.
So I'm showing you how it works in reality with refraction. So the atmosphere is like a lens. It acts like a lens, and it causes objects.
No, it isn't.
I believe it does, Brenda.
No, it actually isn't.
It causes
I believe it
objects. I'm showing you an example here of an increased in refraction, how the clouds are appearing to move downward into the horizon line. And all I'm doing is increasing the incident of refraction. There you go, fellas. So I have another example to show you. Just let me bring it up.
Yeah, the atmosphere is not a lens.
Yes, it is, Brenda.
No, it actually isn't.
Yes, it is, Brenda.
A citation needed.
Yeah, yes, it is, Brenda. It's an atmosphere.
What's your
water? Water refracts light. Over a compounding distance of a few miles, the water will compound, causing light to refract.
No, where's your citation? Where's your citation?
Just to clarify, over a distance of 3 miles,
Where's your
light is
citation?
not.
Okay, listen.
Oh,
I
this
let's
isn't
see.
happening.
Hold
Let's
on,
keep
hold on. I
rambling
want to
about
see your next
blah, blah, blah.
presentation. I want to see your next presentation, please. And then you can get into this with Brenda, because I think she's trying to derail this about lenses or not. I just want to see what else you produced, if that's all right.
Yeah, that's what I get paid for.
Yep, me too. I just started though, Brenda. How's medical in this business?
Medical with the CIA, it's
can you see this,
fantastic.
Ranty?
Sweet.
I've just created two floors. One's an extension of the other floor. So
A
what
lot
I've
of
done
truth
here,
is said in jest.
let me just go back to okay, EV. Let's just go back to rendered. So what I've emulated is the ocean here, and I've emulated the sun and the sky. Okay, and I'm just gonna bring it back here. And what
Ranty,
I've done,
I dropped it in general.
Okay.
what I've done here is I've taken the floor.
Two minute 45.
See this
start.
floor here?
Thank you.
Can you see it? Let's just go to the transformation data. Inside the transformation data, I got an echo there.
Tony.
I raised the plane of the floor to 2 degrees. Okay. Now I've done this because in this 3D program there is no slope or angular resolution limit to the human eye. It's just using straight lines converging into a point, not at any distance based on limitations of aperture or lens size. So we know that the human eye has a 2-degree slope. This can be calculated by taking the person's height, dividing it by the tangent of 0.0217 degrees. In this case, for a 6-foot observer, you'll get the distance to the horizon line. So let's click the camera here. I'm just going to highlight the little camera, and we're going to go view it into this camera, and then we're going to see, hopefully this is, I just pulled this up. Okay, here we go. So there's the sun moving along. It's not, it is what it is. It's just a straight path orb in the sky moving away from the observer. As it moves away, it will appear to move downward based on the angle of the plane meeting the horizon. So if I take the plane and I lower it back down to 0 degrees and forget about the slope of the eye, and then I do with you'll see that it moves away. It doesn't sink below anything.
Sun doesn't
Okay.
shrink with it. Hold on.
The point is that the human eye has an angular limit of 2 degrees. We raise the floor 2 degrees in the program, it will appear to move downward. Because there is a diffraction point, an angular point where light becomes too acute to resolve, and it creates a vanishing line, a vanishing point.
How come
Euclid,
this doesn't?
Euclid,
I have 2 questions.
Euclid
How
calls
come-
it. Euclid says that
How
they
come?
are.
How come this doesn't show reality?
Right, I'm gonna have
Euclid
to.
says there are convergence of light that has no magnitude. So it means it's not measurable, quantifiable. It's an optical effect. I have this crazy repeat, man.
Yeah, that's fine. I'm just having to mute people. Everyone seems to be jumping in and trying to ask questions when you're still presenting, and I've told them not to bother doing that, and it's really pissing me off. I'll take you off or serving you in a minute or so. I'll let you finish up your presentation.
So anyway, I'm just saying that to count for the slope of the human eye, if you do so in this program, by raising the plane up 2 degrees, and if the object moves past it far enough, it will appear to move downward just like in reality. Okay? And
But here's the one other thing. You see what you're looking at here, and this has been demonstrated with many different observations, including Wolfie, etc. And we all see this. Is that very last?
I'm just listening.
The very last part, probably the last 10 minutes or so before the sun disappears, you actually start to lose the definition of the sun. So it seems to, when you got your filter on, it seems to shrink and shrink and shrink and then disappear. So is it the atmosphere that's causing that at the very low levels?
Well, this is not adding any atmosphere in it. So what is happening is the glow is maintaining the relative size of the sun. Now, what I've done, I haven't released any of this stuff yet because it's so, man, when you start getting into this and you just want to get really clean data, it actually takes especially when you don't live around a sunny place all the time. Basically putting a solar filter on a 50 mil lens, setting it up, it will appear to show the sun reduce in size as it moves away. With my experience. But when you zoom in, you have that optical compression. You don't get that detail. I don't know what you're referring to. Did I go off on a tangent there? Something else?
Could you just put an atmosphere at some point? Can you get around to putting an atmosphere in and a little bit of downward refraction? So and refraction that pulls the light down on a flat plane, not refraction.
What I was going to do is I can add a lens in before to simulate it. But yeah, I think because my computer's not that powerful for that kind of effect, like adding in that atmosphere and all that stuff. I'd seriously need a more powerful machine. But I wanted to show that example of the lens, showing you in real time that if the intensity of the refraction is increased, it will actually appear to move stuff downward. I've just demonstrated it with a quick example. Light refraction shows that stuff will get squished downward. And then with this example, I've shown you that, yes, with the rising of the floor to a 2 degree, you will have an angular limit cutoff. I mean, it is what it is, right? It's an example that anybody can do quickly with the assumption of perspective is caused by the eye and not physical arc in the curvature calculators, right?
Cool stuff, right? I'm going to take these guys off mute now, so if they want to chip in, it's up to them. But I think Crow's got a couple of questions for you.
I'm going to try to find another one too. Give me a second.
How come this doesn't correspond to what we see in reality?
It's not what we see.
Well, first of all, it's just a quick example of how objects can disappear bottom up through the angular limit. This is just showing you a physical object. The sun is not a physical object. It's refracted and an apparent position to us. But it's just showing you that if you account for the angular slope, which is in every video game programming, Oculus, they all program for the slope of the human eye. It gives you the 3D perception, depth of field. It's very important to understand perspective, essentially, which is caused by the lens and the angular relation of the object to the lens going through the aperture of your eye. So, of course, you have to assume these factors to present the results. Like one of the next examples I'm going to do is try to put that particular object of light on a bigger, larger sphere above, and have an observer.
Assume, do you mean presuppose? Because that's pretty much what I'm hearing.
Well, I'm not presupposing. I'm not presupposing I'm not. I have this fucking echo. It's crazy.
That's me. My bad. I won't do it anymore. It's me.
That's Crow.
I'm not presupposing the slope of the eye. That's a fact. I'm not presupposing the math. The math is calculable without curvature formulas based on the angular resolution. So I'm not presupposing anything. I'm applying the knowledge into the observation and showing when I apply the knowledge, I get the result. Now, can I apply everything? No, of course not.
Is
but
the
can I apply
plane
angles and distance? Yeah, I can.
Is the plane of the sea in this example, is that flat?
So it's sloped 2 degree based on the
So it's
optical
sloped.
impression of the human eye. So it's basically
So it's sloped. So it's not flat.
Yeah, it's sloped 2 degree.
So
It's flat.
that's how you're
If we were to-
faking. That's how you're faking the sunset, then, isn't it?
No, it's showing you the slope of the angular.
That's how you're
angular-
faking. That's how you're faking the sunset.
No,
By
I'm
you're
not.
sloping.
I'm
You're
faking-
sloping the plane.
If I was to fake it, I wouldn't tell you about the slope. I wouldn't tell you that I rose the ground
Yeah.
2 degrees more on.
Yeah, but that's
So the
that's
point
how
is,
it's
I
that's
tell
how
you-
it's setting.
I tell you.
So it's
I
not
tell you
flat.
to raise. So in your Earth curvature calculators, Brenda, there's an arc. The arc is the position from the observer to the horizon point. Can you tell me what causes that arc?
That would be the curvature of the Earth, wouldn't it?
Okay, so when we look down a hallway, there's a rising of the ground there.
That's
Where's the
because
Earth from there?
hallways are flat.
Okay, there you go. You just got your answer. The guy's a moron.
No,
And you
how
know
is
what,
that an
Brenda?
answer? You've
Bro,
sloped.
You just said
you've
you just
sloped
said the
this
Earth.
this plane.
You just said
so that-
the arc was caused by the Earth curvature,
Yeah.
but then the hallway is caused because it's flat. I don't
Yeah,
need to
it
debate
is.
you, dude. You are just a
How does that
pathetic weirdo.
how does
You are the epitome of the Baphomet.
what you
in
have
the world.
so what
Dude,
you
are the
have
shining
what you have
crown of
here
the Baphomet, dude.
yeah that's fine
all
that's
you
fine
are.
that's fine
You're
but
a
what you
shining
have
crown of the
here
Baphomet.
what you
You're
have here
Grotto,
is a
dude.
plane
You're a
and
Grotto.
you're faking sunsets.
You're a Grotto. No, I'm not. I'm adding
You're
the
faking
slope
sunsets.
angle of the eye. What
You
I'm
show
saying,
me how he's doing it.
I'm not faking anything.
Okay.
I'm not lying about anything. I'm showing you applying what we know to the
also-
observation. You are an example of why humanity is failing, Brenda. You, right here, right now, you are the example.
Fantastic.
Shame on you.
Yeah,
Shame on
he's
you.
right.
I
Yeah,
have a
shame on
question
you,
about
Brenda.
this model. What's the ratio of the height of that whatever
So
object?
they're
you have?
irrelevant. You can
And-
make it as height, distance, and size are arbitrary in 3D program, bro. You can make the plane as big, as small as you want. It will be still arbitrary. Okay.
Yes, that's
It's
why
a
I
3D
asked about the
program.
ratio. That's why I asked about the ratio.
The
not
ratio is
distance. I don't care
irrelevant.
about it.
You can make it whatever size you
The
want.
ratio is very relevant. What are you talking about?
I can zoom in to 1 millimeter, put a camera up and do the same thing. It's a 3D program. They're arbitrary. The sizes are arbitrary. That's just a fact.
Well, okay, then let me tell you why the sun is setting in this model. The sun is setting because you had it set at altitude of 6 feet or 18 feet.
Would you like me to make it higher? It would just take farther to go in the distance. The point is, this 3D animation program won't give you that resolution detail if it's that high, that far away. It doesn't
That's why I
emulate-
said go for
It
ratio.
doesn't emulate reality, dude. It's a 3D
Ball does
program.
not shrink to a point.
So
Then
what
don't
I'm
show it.
showing
It
you-
doesn't simulate anything.
What I'm showing to you is that the object will get cut off by angles. That's it. By ramping up the floor.
It gets cut off by the end of the plane, which is elevated off of flat.
Listen, gentlemen, there is an apparent junction of the flying ground. It's not caused by Earth curve. It's caused by the perspective, the vision of the human eye.
Perspective
This
doesn't
is a
cause
junction.
anything to be obstructed.
This is a junction. This is a junction. It's an apparent convergence of parallel lines. They don't converge. There's no magnitude to them. There's nothing measurable. It's an optical effect. The 3D program doesn't have the aperture of the eye in mind to cause the diffraction point. at 3 miles, because
So
position,
may I speak?
elevation,
May I speak
and
for a
sizes
second?
are arbitrary. Thank you.
So may I speak for a second? So what you have here is you have a plane which is tilted, and you have a sun which is only 6 feet above that plane, and then it gets smaller and disappears behind the plane because the upper that edge is tilted off of flat.
Yeah.
Yes, because he's showing you what the eyes would normally do, which this program doesn't take into account.
You're claiming that the arc is caused by Earth curve. I'm claiming it's caused by perspective. Do you see the difference there, Brenda?
We don't raise
what
the
I'm doing
curve.
This isn't perspective. It's not perspective.
Yes,
It's
he's adding it in.
I'm
That's
adding
why
it
you built the
disappears.
panel.
It disappears because it's
Brenda,
physically
do you
obstructed by the
agree or
plane.
disagree? Do you
No,
agree or
you
disagree that the eye, the human eye, has a 2-degree slope factor? Yes or no?
Yeah, the plane is tilted.
Does the Earth, or sorry, does the human eye have a 2-degree?
The plane is tilted, and the sun is
Answer
obstructed
his
by it.
question, Brenda.
So here, I can show you that it just moves past the plane. It doesn't touch the plane. It doesn't go near the plane. It just moves past it.
Right, it goes past it and is obstructed by the plane because
goes
it's
past
tilted.
the angular
It's
limit that you're
tilted.
allowed to see.
Because he's showing what the eye does, which the program doesn't take into account. So he's put it in.
By adding the floor slope of 2 degrees. Because the eye makes the ground slope into the center focal point position. This is
So
common
you
knowledge.
wait. You just raising
Call
the
it
ground.
perspective.
That's how you're gonna take. That's how you're gonna fix this two.
Didn't raise the ground. I
Didn't raise
sloped
the ground.
it.
That's
I tilted it 2 degrees. I didn't raise it. I tilted
You
it.
tilted
2
it.
degrees.
Then you dropped one side down.
No, I raised one side up.
When you, oh, there you just said you didn't raise the one side up.
It's a slope, dude. 2 degrees. I raised it up.
Yes, exactly.
Yes, because there's a slope to the eye that raises things up.
Right,
You know
and
it.
that's what's obstructing the sun.
Yes, that's what's obstructing
Exactly.
the sun. Yeah, but how about the top?
They'll
then?
get it
Why don't you
eventually,
do the same
Gage.
thing to the top?
It'll take 6 months.
No, that's it. Just raise the top, the bottom. That's what. That's what.
Listen, bro. The human eye raises. Do you agree or disagree that the human eye raises objects into the center focal point position?
I think that
As
the
they move away?
further it goes, the more it shrinks down to a point.
So the ground doesn't rise up to the center of the eye as the object moves away.
The distance, it's going to drop, or height.
So
it's gonna
listen,
drop.
again, I'm asking you. So what you're saying is that you're saying that the object doesn't rise to the center focal point position as it moves away; it drops.
Oh, it stays at the same fucking height.
So it stays at the same height. So when I'm standing, if 6-foot person's moving away from me, they appear to squish into the center focal point position, right?
Equally.
But they're in the center. That the ground isn't risen; it's just an optical thing, right?
I don't know why you got to bring this up.
Right, the ground isn't risen, it's
When the
optical.
distance.
Why do I got to bring this up, dude? It's everything about the argument, dude. It's the fact
No, it's
that you-
not. You've made up. You've added all this bullshit to it.
No, dude. I've totally corrected you, totally embarrassed you, and made you guys do
How?
what I've done.
You just lied in front of everyone and showed everyone that you're a liar. Good for it.
Dude,
Good.
he has
Exactly.
Dude,
He's a
dude,
fraud
dude,
and a liar.
What happened to us, Paige? I thought we were.
I want to talk to Globers, please. Please.
Sorry?
Give him the
It's
2
fine,
degrees and ask him how about the other 15 degrees.
Exactly.
2 degrees. 2 degree slope of the human eye, bro. That's all it is.
That's
2
not enough
degrees.
to make the sun
It's
set.
in measured scientific data. You can go look at the human eye.
Just showed it, isn't it?
Okay, I said I give you that. I said I give you that.
What do you
But
give me?
still, that wouldn't
So
make
this slope is caused by the
make
this
sunset.
slope is caused by the lens of the eye, not your Earth curve calculator, bro.
Okay,
Your
I'm
Earth
with you.
curve-
I said I
Okay, so
agree
listen,
with that.
What
I
causes the
agree
arc?
for the sake of
What
the
causes
conversation.
the arch in your Earth curvature calculator then? What causes
I
that?
said I'm with you. I said I
Listen,
agree for
I don't
the
care if you're with me. Answer your question. What causes the arc in your Earth curvature calculator?
Curvature.
We're not talking about the curve.
I'm asking
We're
you,
talking
Pro
about this
XP.
flat Earth.
I'm asking you for intellectual honesty
You are
here.
showing a
What
model
does the geometrical
and it's
calculator
fake.
calculate the arc as?
What, are you scared? Why are you running
I
from
think
the
it's a fair
question?
question. It's a fair question, bro. It's a fair question. You want to answer his question, and then he'll answer
Answer
yours.
the question. What is the arc in your Earth curvature calculator?
The arc, the curvature of the Earth?
Where is perspective then? If we're talking about the 2 degree slope, where is it in your Earth curvature calculators?
It is invested in the curvature calculator.
Where? Can you show it to me?
The curvature calculator measures the angles of the base of the target and the top of the target, and then convert that into distance or height.
So let me
it's all
give
about
you some
angles.
math. Let me give you some math. What's 2 times 0.0217?
Let's say again, let me hit a calculator.
Yep, take 0. Okay, so what we're going to do is an observer standing on the shore 6 feet tall is going to have an angular resolution of 0.0217 degrees. At a distance
okay.
of 3 miles,
Yeah,
at a distance
I know
of
this
3
equation.
miles, at a distance of 3 miles, there's going to be 6 feet of hidden. Okay?
Yeah.
It's an easy calculation. We can do this. Now, let's add another for the refraction effects. Let's add another, that's double the degree of the human view, which works out to be 0.0434. Let's divide it by the tangent of 6 feet. Tell me what the radius is.
Just leave it here. It's fine.
Wow.
Yeah, the radius will be the radius of the Earth. Yeah.
There you go. So I'm using the angular resolution of the human eye to calculate the radius of the Earth. Now, tell me how that works.
And based on that, because the program does not simulate that, so you make some compensation, and instead of that thing, you elevated the
You didn't
surface
even
by
hear it.
2 degrees.
Broy,
No, I'm agreeing with you.
I just
I'm
told
agreeing
you
with
that I used the eye formula to calculate the radius of the Earth. No geometry, sir. Nothing based on an arc. Nothing. It's an assumption from an angular resolution factor of the human eye. Now we can determine the distance of hidden objects up to a certain distance using the Rayleigh criterion. It's a very easy formula to do. Just take the degree of the observer's height, times it by 180, divided by pi, times it by the distance, and you will actually get the hidden. Which you
Yeah,
guys
I tried it.
wait,
It
listen,
tried it. It works. It works.
Yes, it's because it's based on optics. It's nothing to do with physical curvature.
No,
So
actually,
listen,
it's the inverse of the 8-inch per mile square.
it's the hijacking. Yeah, the 1.22459 miles is the same as 0.0666 feet, which is the same as 8 inches, dude.
Yes,
That's
yes.
why your ball doesn't work, and why I can prove the radius wrong. And not only that, the Black Swan proves that you can't have a radius any bigger than 1.22459 miles for an observer.
The Black Swan have a horizon higher than the eye level. So
there is no
goodbye.
radius of the Earth, my friend.
The Black Swan have the horizon higher than the eye level. So leave this apart. So, it would be concave. Or
You're
convex.
forgetting the 2 positions of the platforms are 3 miles apart. There's no dip, no drop, no curve, bro. You
I'm
understand
talking about
that
the horizon. The
Listen,
horizon is higher than eye level in your
model
God
says-
image.
Your model says that at 1 foot off the ground, 1 mile, 1.2 miles away, that's where the horizon exists. If the horizon is anywhere farther than that, then your radius is not 3,959 miles. This is
So
what
how
you
the
guys-
horizon works in this
I've tried to
demonstration
show
you have
you.
here.
I've tried to show you Blender, showing you flat Earth, elevation, horizontal, and vertical data. I tried to show you the apparent junction, showing you that from zenith position, you can see a 6-foot observer's radius, knowing that the sky and ground touch there, but it doesn't from the observer above, clearly proving it's an optical effect and not physical. But then yet when asking you, what is the arc in your curvature calculator, you have the balls to say it's fucking curvature and negate perspective. Dude, you suffer from...
No. I said perspective is in the calculator. Don't put words in my mouth.
That is what he said.
Now I forgot
it
the
is in the
question that I wanted
calculator,
to
it's
ask you.
called
You are
perspective. It's not,
brilliant.
it's geometry.
I forgot the
It's
question.
geometry,
Yeah,
my friend, not
you're
physical-
very clever.
physical
You're
survey.
very clever. Now I forgot the question because you went on talking for 15 minutes.
Yeah, he's Poe. Definitely a Poe.
Pull your victim card, Crow. Took you a
love
while, but you did it.
Show, once in a while. You know what? I've got so much data, I don't even know what to do with it, man.
Yeah, did you
Hey,
see the
Flat Earth
video
Dad, are you
that I
using
that I
Blender?
showed the gnomon showing the shadow perfectly matches the globe?
Crow
You still didn't
XD,
see
what
it,
you've
right?
done is you've
Did you
taken the
see
gnomons.
it?
Crow
Did you
XD,
see
you've
it?
done. Crow XD,
Did you
what you've
see it?
done-
I'm asking
Hold
a
on,
question. Did you see it?
hold on. Okay, listen, hold on. Flat Earth Data, did you see it? Yes or no? Just answer him.
So yes, I've seen an observation. He's not the first one to do it. I'll tell you where he went wrong. Where he went
Okay.
wrong, he's taking the gnomon and matched it perpendicular to the North Pole, which you would do on a flat plane. In other words, along one straight line, you would have all the poles set up 90 degrees. That's all he did on his ball, is take the
That's
gnomons,
the one I showed
line them
on
up.
Ranty.
Listen, line
No,
them
that's
up
not
at 90
no,
degrees.
that-
you
no,
just
no,
put
you
them on a
didn't
straight
see
line
it.
on a flat plane on a ball. That's all you
no.
did. That's all you
No,
did.
you didn't see it. You're lying.
Yes, dude, that's all you did. Anytime
No.
anybody takes a gnomon and makes it to
Oh my
perpendicular,
God.
anybody takes a gnomon and puts it perpendicular to the North Pole and then tries to put it over a 90
That's
degree,
not what I've done.
45 degree, and
Ranty,
another
I'm
90
sending the
degree.
link
Give
here
me a
so it
break.
be in public. You'll be embarrassed in public now because I'll send the link here in the show topics. Thank you.
You didn't prove anything, dude. All you did was line up your gnomon.
And you proved that you're
perpendicular
lying.
to
You
the
didn't
North
see the
Pole.
video that I uploaded.
What I've proved
so
is
everyone
that
witness
along a
this.
straight line-
Flat Earth Data is
along a
lying. He
straight
said he
line-
saw
Of
the
course
video,
he
but
is.
he
He's
didn't.
he's a fraud. He's a fraud. Of
Along a
course he
straight
is.
line. You
No,
take
it's so
poles,
great.
they'll match shadows. Along the curved line, the poles won't match shadows. It's rudimentary, basic shit. Anybody
You're
can do.
talking about the demonstration I made on Ranty live, but then I uploaded a video. I showed you the link, and I'm
Are
asking
you
you,
taking
did you
your
see
gnomon
it?
and making it perpendicular to the North Pole? Yes or no?
So you didn't see the video?
Are you taking the gnomon and putting it to the North Pole perpendicular? Yes or no?
No.
Yeah.
So then how are
you didn't,
you
you
making
didn't
it
see it. You didn't see it.
This priceless. He doesn't do it. Fantastic, dude. That means you've just
I
proved
did
that
it
over
the
a
way you
straight line-
asked it, and
over a
I'll send the
straight
link.
line-
The link now in the show topics. Thank you.
Anybody can do it. Anybody take a straight line, put two poles on it, 90 degree perpendicular to each other. They'll have the same angle shadows.
No 90
Curve the
degrees.
piece of paper,
No.
curve the piece
Never.
of paper with the two poles on it. One's at 90, one's at 45. The angles
No.
don't match along the same line. Yes, this is a
Where
fucking
is show
fact.
topics? Show
It's a
topics.
fact.
Now I'm
Anybody
sending it.
who does
right.
this observation will prove me correct.
Show topics.
I've already done a demonstration in Blender.
Red
proving
herring.
correct. Dude,
Or straw
along
man,
the
I
same
don't know.
straight line, if there's a curve, you can't have the same angles. It's impossible.
Ranty, I've just sent the video that I made in response to Flat Earth Data, and it's in show topics, so everyone can
Okay.
see it now and know that you didn't see it and you were lying.
Because, dude, the only way for you to get angles to work on your ball is to put them
So you
perpendicular
just
to the North
assumed
Pole.
that I did what
No,
you
I
say
learned it
exactly.
from a science channel again. Crow XC. This observation I did didn't come from me. I watched another science channel do it, and and they show you what the error is. Then they show you what to do to fix the error, bro. It's on my channel. I don't know if you want to play it, Ranty, but it's priceless. Because what they do is they fucking lay the gnomons down on a straight line, is what they do. Because that's the only way you can get matching shadow angles, bud.
Done
Story, end of
exactly
story.
what you did in Blender. Exactly what you did in Blender, but I did it correct, unlike you.
I took it from a science channel, bro. So guess what? I'm glad you posted your video up because the other science channel will show you the glaring error between the two gnomons. He actually uses 3 gnomons with sundials on them, showing that one at 90, one at 45, and another one at 90.
Why are
The one
you
at
lying?
45,
That's
the one
not
at
what I'm showing in
45,
this video.
the one at 45 degree at around 10:30 doesn't match the North Pole time zone. The angle on the sundial. Okay. So what he says, how do we fix it? We take the gnomons and we tilt them to a 90 degree. So along a straight line, they would all be perpendicular to each other. You can
You're
demonstrate
talking to
this
yourself.
over and
I
over
didn't
again.
do that. I didn't do that.
I don't need to watch your shit, dude. I already proved it.
Yeah. Okay.
Done.
Okay.
Bro.
What's
And
the
nobody-
science,
nobody
what's the science video you keep talking about that you're relating this to? Have you posted it
So one
anywhere?
second. I'll get it. 1 second.
This is the one that you started. This whole thing started on, right?
So do you really think you're going to
So
make
what
a lot
did,
of money
I
grifting
watched the
this?
Science Channel say there's errors on the ball. I was like, oh, errors on the ball. Let's check it out. So it shows you along one longitude line, two positions, one at 90 degree, one at 45 degree. When the rotation of the ball happens, the one at the 45 degree will be off from the one at the 90 degree along the same longitude line. Why that matters is because that's how time zones work. That proves that time zones don't work on a ball. Bottom line, because they're off. And the distance is only at what, a few thousand miles along the same longitude line, and there's an hour discrepancy between times? I don't think so, dude. And this is repeatable,
You don't know what you're talking
demonstrationable.
about.
Anybody can
And
do
there's-
this.
there is no Science Channel that said it's just made up, something you made up.
Yeah.
It is.
Yeah.
Give me a second. I'll show it to you. 1 second.
So Flat Earth Data.
Grab your panties, guys. Grab your little panties, Globers.
Do you really think?
Do you really think?
Do you really think that? Do you really think that you're going to make a lot of money grifting this? I mean, Nathan's got it sewed up.
For real. Good call.
I have a book coming out. You
I
can buy
mean,
my book.
Paige and
Done
Write the
with my-
Hand are dumb as fuck. You could probably cool down.
It's not a great idea.
I bet it's
Back in the day, they had
too.
Why is everybody talking?
Back in the day, they had Protestant. Back in the day, they had the Protestant Reformation, where people went door to door preaching the word. Well, I have a book that's pretty much done. I'm almost finished it. I just got to put all the observations. Ranty, thank you for your
Flat
your
Earth is
last
dead, dude.
observation.
There's not going to be
Sugar
much.
water.
There's not going to be much.
So what
to
I'm going
sell
to do
here.
is, let me ask you this question: if this is a good idea, once my book is done, it'll actually be hard copy and digital. But I'm going to walk door to door with the hard copy first, just like the Protestant Reformation did. And I'm going to go door to door selling the book, documented. What my plan is to raise some money from GoFundMe to go from West Coast Vancouver all the way to East Coast on a backpack with books to sell the books.
Quite literally a grifter. Brenda, you were right. He's quite literally.
So I want to do it for the documentary because I want to see the response from province to province. So far my tests that I've done, it's a very small fringe attitude that's online here. This is a small dark corner of the web. There are closet flat earthers. There's people that just don't really fucking care, and that's the majority.
Yeah,
of the people.
look at Google Trends. Look at Google Trends. It's going nowhere. It's going nowhere.
The best no, it's not though. That's the best part. It's really not. You have to realize first
Google
of all,
Trends.
Flat Earth is no longer censored. If you guys thought it was censored, it is no longer being censored. There's tons
It
of
never
evidence.
has been.
Exactly, Brenda. It's never. At first, we were under the illusion that it was. It's not. There is a movement here that wants to undermine all of the foundations of the world, and flat Earth is perfect.
Ignorance.
And
No,
the
we want-
cosmology is Babylonian and Chinese. That's the funny thing about flat Earth. So you have a movement in here that is using the truth to bring about change. And this will change everybody. It's changed you, Brenda. It's changed Negator. It's changed everybody's behavior, including my own.
I think
Right?
it's amazing that 1,000 or so odd flat earthers think that they're smarter and more intelligent.
No,
than
dude.
the rest
The
of
more I
us.
learn, the more stupid I know. The more stupid I am. That's what I
that's
realize. The more I know, the more I don't know. That's the truth. Because there's-
Google Trends says Flat Earth has been rock bottom since March. I mean, it's not going anywhere.
Brenda, well, you know what? You should pack her up and head her out then, bud, because there's no reason to show up anymore. You're wasting your life. The point is, I'm here to document this kind of stuff. I've got enough of it where it's overkill. I'll probably spend. I haven't even began to really edit it much.
To be honest, Flat Earth Data, you're coming in on the tail end of it. The time to have gotten into Flat Earth was maybe a year or two ago, and you're just getting on the end of it, and it's just not going to pay off.
So what do you think? What do you think I should sell the book for? $20, right? $20 is a good price for the book. In the book, there'll be
Are you sure? Why wouldn't you
observations.
just give it away? Hey, why wouldn't you just give it away if it's such amazing?
Bro, 1999, man. 1999.
I don't know about that. I think $20.
I want to hear what he's going to spend his money on.
You guys don't understand my history. I was a professional peddler for 10 years, okay? Meaning I had no problem approaching businesses and stores selling hats, hoodies, t-shirts, and sunglasses. It was natural to me.
Salesman,
okay?
a professional salesman. Wow.
It was natural to me. But the point is that when I was researching the Protestant Reformation, a little bit that I know of it, it was the only way that wasn't stoppable, because once one person got it, they wanted to share it with somebody else. It's different than online. Now, I don't know if that psychology is still present in this day and age. It is with children with little fucking toys from McDonald's and shit. But the point is will it affect people in a way that I want it to do? It's a psychological thing for me. this whole flat Earth is a psychological test on the human spirit, the human mind, the humanity that's within you. Where
I
does
got
it
a
come
serious.
from?
I got a serious question. This is a serious question for you. In the future, growing now, there's going to be more and more. There's several companies that are putting rockets into space, and there's going to be space tourism. The prospects for your book don't look very good. It doesn't look very good.
Get rid of the Concorde, Brenda.
No, I'm asking.
I'm stop making parts for it.
Why did you get rid of the Concorde, bud?
Just listen. Just listen.
Space
Let
travel.
me finish
20
a
minutes
fucking
from here to
sentence.
Paris.
Holy
rid of it. Why did you do
shit!
that?
Holy shit! Just let me finish the sentence.
I'm
The
not
prospects.
chicken.
The prospects don't look good, given
Great.
what's coming
Signing up.
down the
I'll
pipe, right?
Take a video of me and my flat Earth book from fucking the tourism thing. What I'll do, Brenda, is I'm going to sell so many flat Earth books that it's going to raise enough money for me to take this
I
tourism
guarantee
ride.
you get slapped in the face more than you sell books.
Guess what?
But those people aren't going to buy it because they're going to go on YouTube and they're going to see people going into space on a regular daily basis.
What space? Is it outer
They're
space
going
or
to see
space?
them. They're going to see them on their
difference between
TVs
space and outer
going into space almost every
difference
week,
between
if
space
not
and
every
outer
month.
space, Brenda? Brenda, is there a difference between space and outer space?
That's not the point.
I
The
saw
point
people in
is
space on-
Is there a
those
difference between
people,
space and outer space? I'm
the
just
people,
curious.
your
Am I going to space
customers.
or am I going to outer space?
Flat Earth
Am I
data.
going to
This
space
is
or am I
about
going to outer space?
this is about your market and your customers.
Am I going to space or am I going to outer space? I've been to space already. I've been
I'm
35,000
talking
feet up.
about.
Actually, been up to 48,000.
That's not
before.
space.
The point is,
35,000
I've been
feet
to
is not space. It's not space.
Well, I've been to space.
That's not space.
Well, where's outer space then?
That's
Aren't-
not space.
Aren't we going to outer space or are we just doing space travel?
So that none of
Where
that
does
is
it classify
space.
outer space then?
So you're just.
Well, then where
you're
does outer
just-
space classify? 60,000 feet outer space? Where's outer space to you, bro? Where's it at? Because I've been to space before. I've been to space a few times.
You've never
man. I
been to
traveled
space. You've never been
Yes,
to
I have.
space.
I've
No, you
never
haven't.
been to outer space. I've never, ever traveled through outer space. Tell me where space and outer space begins and ends. Please.
How long have
Come
you been in
on.
this
So,
argument?
so I just wanted to
380,000
point out to
feet,
you
is that outer space?
that your
Is 380,000
potential
feet outer
customers.
She wants you to get your
I
life
just want to- I just
worry
wanna
about
say a
things that aren't
sentence.
actually happening yet
They are
and
happening.
not do something because she thinks something else is going to happen in the future.
Because it is going to happen in the
Got
future.
stock in Virgin Galactic. It's already
300
happened.
Oh, when it happens, then he can change his
His
approach.
cus-
But until then,
his
it's not
customers-
happening.
His customers are going to be seeing people go into space on a monthly, if not weekly basis.
Yeah,
Every
when
week.
that happens,
outer
he
space
can
is
change
space.
his approach. But it's not
And so
happening
I'm
at the
saying,
moment.
Just like we're going
I'm
to the
saying
moon right now.
that this is a
Is it
bad
outer space or
this is a
space? There has
bad
to be a
market
difference,
to get
Brenda.
into. This is a bad market
Brenda,
to
is
get
it a
into.
listen.
And why do you
Is there-
care?
Is there a difference between outer space and space? And do you know where that
What does
line
that
is?
do with anything she was saying?
Because I've been to space, bro. I've never been to outer
Sure,
space.
you've been to space. That's fine. You've been to space then.
Well, what's outer space?
Outer space must be where you haven't been then.
Have you been to outer space?
No, hell no.
Has man been to outer space?
If you're the way you're calling it, yeah. If it's above
The way
40,000
I'm
feet,
calling
yeah.
it, I'm saying it's outer space. Is it not outer space?
You're saying space is 40,000 feet.
I'm saying that I've been to space, which is 40,000 feet. I've never been to outer space.
So outer space would have to be something above.
Bro,
40,000.
I'm 6 foot from my spaced out from my fucking computer. I'm in space right now. I'm in my living room. I've got space between me and my computer. I don't have outer space between us.
Speaking of space, I have a question.
Blurring lines.
I have a question for Crow.
No,
These
you're
are the
blurring the line
kinds of
between space and
semantic
outer space.
games
There's a
that
difference.
con artists get into.
No, you
He
guys
didn't say
are
he was a
blurring the
peddler,
lines by telling us
Speaking-
there's no difference between space and outer space. That's false.
Speaking
No
of
one said
space,
that.
I have a question for Crow, if he's available.
Yeah.
Crow, is that you?
Yeah.
Hey, so I was watching a video the other day, and it's they on the ISS. They're taking like squeezable bottles of what appears to be water and doing this high tech science and squeezing it, and this water comes out, and it kind of takes a shape. And I
Yeah.
was just wondering why it takes that shape.
Surface tension.
Okay. And so what shape are planets
Spheres.
and stars, right?
Same shape.
What creates that shape?
Gravity.
Okay.
Great
Do you
question.
see the conundrum here?
Do you not see?
No conundrum or anything. I didn't say the water in the space
Surface.
station is because of gravity, because it's very small for such a small object.
Oh, okay. So that water bubble there in the ISS has its own gravity, so it's not surface tension.
No, it's surface
like
tension.
you just said.
Surface tension. I said
Okay,
surface
cool.
tension.
And
I
what
didn't want
what
to
cre-
say gravity
yeah,
because it's very small.
and
Almost nothing.
what creates your round planets and round balls of gases? Is it surface tension or?
The huge mass.
Well, okay, now we're scaling. Scale has a
Yeah,
big difference.
yeah. Scale matters.
Okay. So let's just say I was made of stuff from this Earth, right? And let's say it's flat. I'm made of iron, carbon, all the goodness, the minerals of this Earth. Would surface tension possibly come into play for me and you?
On that big scale, surface tension. Even if gravity was not there, I don't think surface tension.
But I'm a small
would
scale,
survive.
right? But I'm small.
Oh,
though,
okay.
right?
Small scale.
Yeah,
Yeah. Okay.
Yeah.
Yeah. Yes. I've seen people make bowls of water on the zero G airplane, so it can be replicated once you eliminate the downward acceleration.
So what is the cause of the shape? Is it surface tension or gravity?
On that small scale, only surface tension.
On a small scale, it's only surface tension. That's what you're saying?
Yeah.
Okay. How do we ramp up the scale? Like when do we cross over into, well, now we need gravity because surface tension falls apart in space?
Okay, I'll tell you something. Find something that's called gravity calculator, and you can play around with numbers and masses to get a feel of what mass that's required to start showing the gravity. So
That water bubble there in the ISS, is there a minute amount of, let's say, evaporation or on that surface tension there, that little ball? Do you think just through your natural way that elements work, do you think all the water is strictly contained to that surface tension ball, or is there some just kind of trying to get out, like trying to get into the air there, right? Due to certain reactions between
Well, there's
yeah, if you breathe in it, might lose some drops.
there's
and
one
fly.
video where he puts what does he put into it? He puts a Mentat, or does he put in carbonated water or something like that? And you can see the little bits of carbonation popping outside of the ball.
Cool. And is that a reaction due to gravity or due to just like chemistry, kind of?
It's chemistry. It's due to the fact that because it's carbonated, it sends out tiny little droplets that are able to break the surface tension of the ball.
Cool. Did they zoom in on that so you could totally see what those little bubbles were doing, or you just saw some bubbles pop?
I saw briefly one video where they had a water bubble, and it seemed to have I don't know, some other substance in it, whether it was carbonated water or a fizzy tablet of some kind inside of it, and there were tiny little droplets that were popping outside of the ball. It was kind of cool. I didn't really.
Yeah. So even in that demonstration, and I know I'm talking about spheres here, so flat Earth don't kill me, but there's just thinking about this, critical thinking. Just because it takes a shape in zero gravity, and then you look out into space and you see the same spheres, but you call that gravity, the reason why it's a sphere, can
They're bigger.
can the water in the ISS, that water sphere, can it just leave and go wherever it wants and just fuck off into? Can it just leave?
The real question is, can it ever?
Yes, if a drop escaped from that sphere, it will not get back again to it. Because
How come they don't? How come it doesn't break into a bunch of little?
Little flat spheres, little flat things. I don't know.
Well, it would take energy. Without any energy, the ball would just sit there. It would never move.
I think maybe some glober told you that this is gravity, and but no one believes that. It's not gravity.
There's people that there's globers out there that give wrong answers because they don't know, or they panic and they give the wrong answer. That happens. I could give wrong answers. You should check for yourself.
I once used that gravity calculator, and I said let's have two jumbo jets touching each other, and what's the force required to separate them, just to make them move away from each other, and it was something very tiny. Can't remember exactly, but yeah, even that weight, because I couldn't make them like go through each other. I had to make them just touching, and that means that the center of mass of the two jumbo jets is like 6 or 10 meters away.
Yeah, but in astronomy, there's a certain point, a certain mass, after which, like asteroids are different shapes. They're often odd shapes, like a dumbbell. There's a dumbbell asteroid or stuff. But once they accumulate enough mass, they will always be spherical.
Yeah, I heard about that.
I don't know what that mass is. I'm sure they've got it figured out, though.
Well, looks like Phase 1 turned this conversation into Glober's conversation and left.
It's fine. It seems to have calmed down quite a bit.
Yeah. So, did you see the video?